kolegë, të nderuar kryetari i Akademisë së Shkencave të Shqipërisë, profesor, antar të kryesisë së Akademisë së Shkencave të Shqipërisë, të nderuar akademik, pjesëmarrës nga industria. Shumë faleminderit që keni ardhur sot në këtë takim të pestë, workshopin e pestë të takimit midis punonjësve shkencor në fushën e nanoteknologjisë dhe përfaqësues nga industria. Është kënaqësi pra që jemi të gjithë këtu sot. Dua të përshëndes edhe kolegët që janë të pranishëm online nga Kosova, nga Maqedonia e Veriut dhe të tjerë që nuk mundën të jenë të pranishëm fizikisht. Unë do doja të ftoj së pari për një fjalë përshëndetëse profesore Anila Hoda, sekretaren shkencore të Akademisë së Shkencave të Shqipërisë, duke falenderuar me këtë rast për mbështetjen që Akademia e Shkencave të Shqipërisë i jep kësaj qendre pra nanoteknologjisë, sikurse edhe qendrave të tjera pranë Akademisë së Shkencave të Shqipërisë. Faleminderit Anila.
I nderuar zoti kryetari i Akademisë së Shkencave, profesor Gjinushi, i nderuar profesor Merkoçi, të nderuar kolegë pjesëmarrës, të nderuar përfaqësues të universiteteve, institucioneve kërkimore, por edhe të industrisë dhe biznesit që jeni sot të pranishëm. Të ftuar, zonja dhe zotri, është një kënaqësi dhe nder i veçantë që në emër të kryesisë së Akademisë së Shkencave të Shqipërisë t'ju uroj mirëseardhjen pikërisht në workshopin e pestë. Shkenca e nanoteknologjisë takohet me industrinë, kërkimi, inovacioni dhe bashkëpunimi. Aktiviteti i sotëm sjell së bashku shkencëtar, inovator, sipërmarrës, politikbërës dhe partner institucional rreth një objektivi të përbashkët që është forcimi i lidhjes ndërmjet ekselencës shkencore dhe zhvillimit të shoqërisë. Është veçanërisht inkurajuese të shohësh një audiencë kaq të larmishme, të bashkuar nga bindja se shkenca dhe inovacioni janë ndër motorët më të fuqishëm të përparimit në botën moderne. Nanoteknologjia është një nga fushat më premtuese shkencore të shekullit të 21, ku aplikimet e saj po transformojnë shëndetësinë, bujqësinë, mbrojtjen e mjedisit, prodhimin e avancuar, inteligjencën artificiale dhe shumë sektorë të tjerë që janë themelor për zhvillimin e qëndrueshëm ekonomik dhe shoqëror. Ndërsa sfidat globale bëhen gjithnjë më komplekse, nevoja për kërkime ndërdisiplinore dhe për një bashkëpunim më të fortë ndërmjet akademisë dhe industrisë bëhet gjithnjë më e dukshme. Ky workshop ofron një platformë të shkëlqyer për një dialog dhe bashkëpunim të tillë. Akademia e Shkencave të Shqipërisë ka njohur prej kohësh rëndësinë e mbështetjes së fushave të reja dhe perspektive të kërkimit shkencor. Krahas instituteve të saj të përhershme, Akademia ka krijuar njësi të përkohshme kërkimore në fusha strategjike të shkencës, me synimin për të promovuar ekselencën, për të nxitur inovacionin dhe për të krijuar mundësi të reja bashkëpunimi e ndërveprimin ndërkombëtar. Këto njësi janë konceptuar si katalizator të zhvillimit shkencor dhe si instrument për adresimin e fushave me rëndësi të veçantë për zhvillimin e ardhshëm të vendit. Ndër këto iniciativa, pikërisht NanoAlbi, njësia juaj, përfaqëson një histori të vërtet suksesi. Në një periudhë relativisht të shkurtër, NanoAlb ka arritur të ndërtojë një komunitet shkencor dinamik, të tërheqë studiues të talentuar, të zhvillojë bashkëpunime ndërkombëtare të nivelit të lartë, të sigurojë projekte kërkimore konkurruese dhe të krijojë ura të rëndësishme bashkëpunimi me rëndësinë dhe aktorët e inovacionit. Arritjet mbreslëndse që do të prezantohen gjatë këtij workshopi dëshmojnë qartë cilësinë shkencore, rëndësinë dhe ndikimin e kësaj nisme. Akademia është veçanërisht shkrenare që NanoAlb është shndërruar jo vetëm në një pikë referimi kombëtare në fushën e nanoshkencës dhe nanoteknologjisë, por është gjithashtu një aktor i rëndësishëm rajonal, duke kontribuar në rritjen e dukshmërisë së shkencës shqiptare në hapësirën europiane dhe ndërkombëtare të kërkimit shkencor. Përmes veprimtarisë së saj, NanoAlb ka treguar se investimi strategjik në shkencë mund të gjenerojë dije, inovacion dhe mundësi konkrete për zhvillimin ekonomik e shoqëror. Në këtë kontekst, desha të shtoj që së fundmi, bashkë me profesor Merkoçin, ne ishim në takimin e Asamblesë së Përgjithshme të All European Academies, ku një vend të veçantë ju kushtuar zhvillimit të qendrave të ekselencës shkencore, specifikisht në Shqipëri, por edhe në rajonin e Ballkanit, ku natyrisht u morën si shembull ose si good practice dy qendrat, Nano Albi, që është qendër e përkohshme, por që me shumë shpresë dhe me shumë mundësi së shpejti do të transformohet në një qendër të përhershme, por edhe për qendrën e kërkimeve të bioteknologjisë dhe gjenetikës. Pikërisht për këtë arsye, Kryesia e Akademisë e shet ardhmen e Nano Alb me optimizëm të madh. Ne shpresojmë sinqerisht që rritja e vazhdueshme, ekselenca shkencore dhe njohja ndërkombëtare e kësaj nisme të mundsojnë së shpejti transformimin e saj nga një njësi e përkohshme kërkimore në një qendër ekselence të përhershme pranë Akademisë së Shkencave. Një zhvillim i tillë do të përbënte një hap të rëndësishëm për shkencën shqiptare, duke krijuar një qendër të qëndrueshme për kërkimin e avancuar, inovacionin, transferimin e teknologjisë dhe formimin shkencor, në shërbim jo vetëm të Shqipërisë, por edhe të rajonit më gjerë. Programi i sotëm i këtij workshopi pasqyron në mënyrë të shkëlqyer këtë vizion. Ai paraqet kërkimet avancuara dhe aplikime inovative në fusha që shtrihen nga shëndetësia, bujqësia, deri te qëndrueshmëria mjedisore, inteligjenca artificiale dhe inovacioni industrial. Gjithashtu ai vën në parë rëndësinë e partneriteteve ndërmjet akademisë dhe industrisë, duke treguar se si zbulimet shkencore mund të shndërrohen në zgjidhje konkrete që i shërbejnë shoqërisë dhe kontribojnë për zhvillimin ekonomik. Kryesia e Akademisë së Shkencave mbetet plotësisht angazhuar në mbështetjen e ekselencës kërkimore, forcimin e infrastrukturës shkencore, promovimin e bashkëpunimit ndërkombëtar dhe nxitjen e transferimit të dijes dhe teknologjisë në shoqëri. Ne besojmë se investimi në shkencë është investim në të ardhmen dhe se institucione të tilla si qendra Nano Alb luajnë një rol jetik në formësimin e kësaj të ardhme. Dëshiroj gjithashtu të shpreh një vlerësim shumë të sinqert për profesor Merkoçin, por edhe për grupin e ngushtë organizator, për përkushtimin, vizionin dhe punën e tyre në organizimin e këtij aktiviteti. Një falenderim për të gjithë partnerët që marrin pjesë në realizimin e këtij aktiviteti, për folësit, për përfaqësuesit e institucioneve të ndryshme pjesëmarrëse. Dhe së fundmi, urimi që të keni një ditë sa më të suksesshme, sa më të frytshme, me prezantime dhe me debate konstruktive në të mirë të zhvillimit të shkencës, veçanërisht të nanoshkencës dhe nanoteknologjisë. Suksese!
Welcome in this fifth workshop, Nanoscience Meets Industry. So it's a pleasure to have you all here. A few words about this virtual center of nanotechnology, NanoAlb, next to the Academy of Sciences of Albania. For those who do not know about this center, and probably it's the first time you are here, NanoAlb is a center, virtual center of nanotechnology that is created from Academy of Sciences of Albania since 6 years, and we are organizing several activities like this, and today this event is devoted to collaboration of scientists working in the field of nanotechnology with industry. We consider, and you all know, the importance of collaboration between the science and industry. This is something that is very, very important, not only to find resources, but we consider that the science we are doing should go to the society, and the best way to go to the society, to bring back the investment that society is doing to scientists, is to collaborate with industry and solve real issues that are with interest for everyone. By the way, the Center of Nanotechnology, NanoAlb, has been supported since several years by Academy of Sciences of Albania, and we have been running a project, we call these Ignite projects, funded by Academy of Sciences of Albania that aims to support the collaboration between the different groups within NanoAlb Center with an external group, a third group from abroad. So these are very, very interesting projects, as the name is specifically saying Ignite project that initiate this kind of collaborations. And in this workshop today, we are going to show also some of the most important achievements and those that are probably with interest for industrial collaboration. So this is a very good opportunity, a win-win opportunity for both to find out possible collaborations. So this is all I wanted to say. Just as a final remark, the Center of Nanotechnology next to the Academy of Sciences of Albania is organizing also this year for the 6th time in a row Nano Balkan Conference, which is one of the most important nanotechnology event in the world. You may have a look to the website of the conference. There are around 75 keynote and invited speakers, well-known names in the field of nanotechnology. So it will be a great occasion also for not only for us, for people working in academia, but also for industry to be present in this event, because you'll have the possibility to meet colleagues all over the world, well-known names, and this will help also to bridge and to connect both sides, and also to push the collaboration, not only for Albania, but also for the region and also abroad. So this is all from my side. I would like now to invite my colleague, co-coordinator of NanoAlb, and by the way, thank you very much, Kledi, and also Professor Majlinda Vasiari for organizing this meeting. And now we start with the first session, moderated by Professor Gjagiu.
Good morning, everybody. It's my pleasure to moderate this session of the 5th workshop, which bridges the interest of NanoAlb groups and industry. And for us, it's really a pleasure to reorganize this event again in Albania. First, I want to greet the head of the Academy of Sciences of Albania for supporting this event. So Honorable Professor Gjanushi, Honorable distinguished guests, and dear professors, it's my pleasure to announce the first presentation for this event, which will be assessment of antiviral and SARS-CoV-2 and antibacterial activity of environmentally friendly nano-coated cement-based composite tiles and panels, which will be presented from Professor Korpa, but in his absence, it will be his PhD student, which will be online, because this event, as it is announced, will be a hybrid event. Therefore, I have the pleasure to invite Dr. Dervishi, which will be presenting online.
Thank you very much, Professor Kledi. I don't know if I should present in English or in Albanian. And how can I share? There is a problem with sharing the PPT. I cannot share my PPT. It says is disabled to share. Host disabled, attendance, screen sharing. I don't know what to do. If there is any help. Maybe I should send you my PPT and you can share it. I don't know.
Sarah, it will be great if you will wait for us a couple of minutes until we establish the system.
Okay, okay, great. I thought it was my problem.
Okay, due to some technical problems, we'll just go on with the next presentation,
Okay, great.
which will be the next generation furnaces for single crystal growing of electronic and solar silicon. And I have the pleasure to invite here the CEO of the Shiftia Technologies, which will be Dr. Arjan Shiftia.
Hello, everyone. It's a pleasure and honor to be here and talk about our project on solar silicon and semiconductor silicon. Yeah. Yeah. Oh, there. Okay. Thank you. It was sad that the previous speaker couldn't continue her presentation, but things happens. We always have technical issues. So anyway, we're continuing. Next generation furnaces for single crystal silicon, which use both for making photovoltaics and silicon chips for computers and AI technologies and so on. So, sorry, it seems I still have some problems, but always the idea. Go. Yeah, now we're good. Good to go. I think I'm being the guinea pig here, so we're testing all the technology. And life will be much easier for the next presenter. So anyway, the company purpose is to provide efficient, novel ceramic materials to the silicon industry. Why is that important? And I'm going to show in a second, because before I continue with our technology, our process, it's good to know the motivation to doing this work. And oh, sorry. And here we have a. Sorry, can you play this video here? I'd like to continue with showing the global temperature rise in the world in the last century. Can you play it? I'm not sure if I can play the video here. No. So, yeah. I have to be the technical guy too, you know, like in my company, we're also CEOs is also a technical person. And what you see here is the temperature rise above the pre-industrial area in the world. And as you see here, especially above 2000 years, 2000. This is the situation where we are in right now. And so the world is heating up quite fast, actually much faster than it was thought before. This is the real data that shows the temperature anomalies. If you remember from Kyoto Protocol or Paris Agreement, the idea is that we should be able to stop the temperature rise at least below 2 degrees Celsius by the end of the century. Preferably, the temperature shouldn't go above 1.5 degrees, and we are already 1.6. This 2024 is the warmest year, and the predictions are 2027 is going to be even, hopefully not, but most probably going to be even higher temperatures than that. So we are heading very fast towards really, really extreme temperatures. And what we do have, the best tool we have to fight this global warming is, well, renewable energy, right? And when it comes to renewable energy, solar energy is the best tool we have on that. And it is the only technology invented by humans that was possible to reduce the cost by more than 90% in 1 decade. It's a green line here. Sorry, my pointer isn't working, but yeah. Okay, maybe here. All right, this is the green line here. So you can see it. In less than 1 decade, we could reduce the cost dramatically, which is the reason why now you have deployment of photovoltaics everywhere, including Albania, right? So what made it possible for us to reduce the cost? Well, I'll have to go you through the process of how we make photovoltaics, but also silicon chips, because it is basically the same thing, right? So what we do, we start with quartz and coal, carbon materials, right? Quartz is silicon dioxide, is a mineral of silicon. And then in submerged arc furnaces, we produce what we call metallurgical grade silicon, which is only 98 to at most 99% pure silicon. In this state, you cannot use it because impurities are too high. You cannot have collecting electrons to have electrical current. So what we do is we have to purify it and produce a really, really pure silicon, solar cell silicon and semiconductor silicon. Now the difference between these two quality materials is how pure it is, right? For solar silicon, we have 6N. I call it grade 6N, means 99.9999% purity. But for chips, for computer chips, we have ultra high purity silicon. It goes from 9 nines to 11 nines, right? That's the only difference. And the reason why photovoltaics previously were so expensive that people thought, okay, there's no way on earth solar energy is going to be competitive to any other possible source like hydropower or nuclear power or whatever you have, is because we're using waste from semiconductor. And it is extremely, extremely expensive. 1 kilogram of silicon at those times was 400 or 300 euros per kilogram. That's the price. And now it is down to below 30 euros per kilogram. Okay. So from this silicon, which we cannot use it because part of it is amorphous and it is many, many crystals, we're just going to use it. We have to grow it into one single crystal, which is called, maybe you heard it, single crystal silicon. All right. And exactly in this area, there is still a lot to do. This is the front, which hasn't been conquered yet, which I'm going to show afterwards. And this is where we operate as a company, right? But once you make the silicon crystals, then what you do is you make the wafers, all right? Now you cut thicker wafers to make silicon chips, slices, like roughly 550 micrometers in thick. And then you go on to process into chips. But then we have to make squares. So we cut the cylinder into sort of square size and thinner wafers. We do thinner wafers for silicon, for solar cells, because we want to have as many wafers from our crystals so that we can lower the cost, right? Now the cost is important for solar energy. It's not that important for chips. Quality is way more important for silicon chips. So you take these wafers and then you produce. Point here to change the slides and point here. Yeah. So we do. These wafers are turned into solar cells and then into chips, and then afterwards into solar modules and GPUs. And then you have systems like solar farms and data centers. Okay. So cool. Just very short, the process that we use to make polysilicon feedstock to make the crystals. But the process was invented by Wacker Chemie and Siemens process. It is a chemical process. When you take a metallurgical grade silicon, you dissolve it, You react with the hydrochloric acid, you produce trichlorosilane, which is liquid in room temperature, so then you can distillate, and then you purify the silane, which then goes into, we call it Siemens reactor, where the silane is cracked into silicon and hydrogen, and it looks like this. Now, you must probably know that majority of photovoltaics now come from China, and the reason China is a major player now in PV industry is because they bought the licenses and the patents from Wacker and Siemens. They make it 10 times bigger. They lower the cost because the major cost is electricity. It's not labor, it's not raw materials, it's electricity. And then they also reduce the steps. So Wacker had all the steps to go ultra high purity silicon. They cut the process in half to make good enough for solar cells, which is the reason now I'm going to show some data here. 85% in 2021 was produced in China, but look at the graph now. This is China beginning, and then it's China here. Like more than 93%, maybe like unbelievable, everything is in China. And this is the reason, like low electricity, cheap electricity, and then reduce the process. And then make it huge, upscaling to enormous size. Okay? Good. So when it comes to polysilicon producers, Hemlock, American, Wacker, German, Tokuyama is Japanese, Korean, Mitsubishi Japanese, REC, Norwegian. In the beginning of 2001, REC was the largest producer of multicrystalline silicon for photovoltaic. It's the largest in the world. That's where we started with this business. So I just wanted to remember this name because I'm going to come back to it. And then you have, when it comes to PV silicon, all of them are Chinese. Wacker is actually losing more and more the market because now everything is in China. All of them are Chinese. But I just want to focus on GCL and Shinta Energy, if you could fixate the names for the moment. All right, why is this important? Oh, okay. Well, it's not supposed to come here now. Okay, now this is where we are. Once you have the polysilicon, we have to make the ingot, and the ingot is produced in these furnaces. These are called Czochralski furnaces, right? What you do is you have a quartz crucible, you fill the silicon melt, you melt it, and then you start to dip one crystal. Here you can see it, but I'll show you in the video. And in the end, the silicon is like this one here. So once the melt silicon is, the crucible is filled with silicon melt, you dip one single crystal like the size of a finger, and then you rotate the crystal in one direction, you rotate the crucible in the opposite direction, and start to slowly lower the crucible down and pull the crystal up, and that's how you grow the whole crystal. And the speed is 1.2, 1.5 millimeters per minute. That's low. I'm going to play one. This is from the test. I don't know if you can see it. If you could notice, if you could play again, the crystal moving in that direction, in that direction, counterclockwise. On the opposite. I'm not sure if you noticed, but there are some solid particles in some white parts. Can you just play one more time? I just want to now focus on this part. Now, what happens during the whole process is that you have particles, which are impurities from the quartz crucible, and they come from the graphite parts. If they come in contact with the crystals, then you grow crystals on the sides, then you have to stop the process, you cannot use it. So the process is very, very delicate and very problematic and have a lot of issues. So it's not very simple, it's not very straightforward. And it consumes a lot of energy and a lot of time. So when it came to purity of silicon, those numbers that you saw there are mostly focused on metallic impurities and dopants like boron and phosphorus. But since we're growing silicon in quartz crucible and then you have carbon in the system, you cannot remove oxygen and carbon contaminations. And these are a major issue right now. Issues that the industry has been trying since the last 3 decades to get rid of, right? So this is where you come into play. So this is a sketch of the furnace. As you can see here, everything inside it is made of graphite, then you have a crucible and the silicon growing. The problem is the graphite. We are now targeting the first problem, which is carbon contamination. So first we have carbon, which is an impurity that deteriorates the properties, electrical properties of both photovoltaics and silicon chips, right? And then you have crystal loss because of those silicon, the solid particles. When they come in contact with the crystal, they destroy the crystal structure. And that causes a lot of downtime and high maintenance costs. And then they also, due to this reaction, we have high corrosion, which means that these parts need to be replaced continually. And in the best case scenario, they last for 6 months up to 1 year, so every year, after bring up the new one. And then they have extremely high prices. This figure is from GCL, the company which I showed you, remember, because they are trying, they're desperate, trying to get rid of carbon, and they're trying also to save this heat shield, these parts. So they sent me this picture from this operator, their operator. So solution. We have made a breakthrough that we are able to produce silicon nitrides, the only company in the world who was able to produce pure silicon nitride from direct reaction of silicon and nitrogen without catalysis. And this is ceramic material which is have superior properties compared to the graphites. You can check here the hardness and strength and Young modulus, and you compare it to the graphite is much better. And another thing is another different level is electrical resistivity and thermal conductivity. These are the most important part that we need to have because graphite is mostly used as insulating. But graphite is a good conductor of heat and electricity, which is something we do not want to have, right? Some materials is inert with good mechanical properties. We've been making samples, trying to use into melted silicon and see how it reacts to silicon. And one crucible is made of silicon nitride. It's been used 6 times. And this is the only material made so far that can resist silicon because silicon is so reactive, it dissolves anything it comes in contact with. You cannot basically work anything. The quartz crucible lasts only time, just once. Then you have to use the new one. So this particular crucible is 6 times, 6 different rounds. And this is very high purity. When you compare the purity, we compare it with a quartz crucible that the silicon is melted into, okay? And ours is even purer than that, okay? Not going to. They do not corrode. We expect to have very high lifetime, which we haven't tested yet because then you have to test during production. But it is a very simple manufacturing process. These materials could even allow us to crystallize silicon at faster speed, faster rate, which means that we could increase the productivity of the furnace, right? And it has lower cost. So this is the plant that we had in Norway. This is the first, you see here, the first prototype. So what we do, we take silicon powder. We mix it with water and some chemicals to form the geometrical shape, which then is pure silicon and plus binder, like organic binder. And then we put into the reactor. And this reactor actually is a high temperature furnace, vacuum furnace, which was donated by us by REC, the company we just mentioned in the beginning. We got it for free, this equipment, which we already have. And then this is the first radiation shield that we could deploy and use for Cherkassky growth, for silicon growth. And Avin, the guy, if you saw the guy with the crystal, is sitting in SINTEF. SINTEF is the largest research institute in Norway. I'm trying to test it. But unfortunately, the prototype that we made, it was made for Chinese furnaces, and the furnace we have in Norway is smaller in size. So it doesn't fit. So this is where we are. We have cooperation with many manufacturers. I mean, the first we have secured the raw materials from 2 companies. Was Ferroglobe and Elkem is our suppliers. And then we had cooperation with Norwegian Crystals, which is a Norwegian company which had to close down after the war in Ukraine started. Then we have cooperation with Xinte in China, who offered to us to build a company and factory in China. And then Siltronic. Siltronic is the 4th largest producer of semiconductor silicon, and this is the only company we have in Europe is in Germany. Okay, Siltronic did a lot of tests for us, checking the oxygen, because they are mostly focused on oxygen, and they wanted to use this material in the process. And then we have cooperation with GCL. Again, GCL is the 2nd largest in the world. Used to be the largest in PVs and modules. And then we are contacting with Longi right now. Longi is probably known in photovoltaic, a leader right now. So this is the team. Not saying so much about it. Just a few words. Company was founded in Trondheim in Norway, small city of Trondheim with just 200,000 people. It is a student city. Here's the University of Norwegian University of Science and Technology, or University of Trondheim is called it. And here we have also SINTEF, which is the largest research center in the same place. We share laboratories and offices with the university people. And now Trondheim is located in the middle of Norway, which is called the middle of nowhere. But in the south of Norway, in the small city of Porsgrunn, we had this Reja industry park. It's an industrial park. And we had our plant is this one here. And REC was located right here. Okay, so this is where everything happened. Our dream is maybe we have something like this similar in Albania and Kosovo. Okay. Thank you.
I would like to thank Dr. Chiftia for the very nice presentation. And now I open the floor for questions and discussion.
Thank you very much, and congratulations for the technology you have developed. I know this is a very competitive area, not only silicon-based, but also there are flexible materials, graphene also involved. But my question is, how do you see, or is there any plan to collaborate with Albania or with the region?
Yeah.
So, because you are here for some reason. So
Yeah.
can you explain what are your needs and what you expect, for example, from scientists working in the nanotechnology in the area?
Well, the reason I'm here is because I want this technology to be implemented in neither Albania or in Kosovo, one of our countries, right? Because, you know, I mean, developed nations are not nations that just buy products from the other. They have to export something, like they have to. And this is a technology which we have patents, we have developed. And I think it would be very nice if we can have a plant here. I mean, there is the idea. We are in the stage where we want to just build a pilot plant, manufacture prototypes, which are tested at GCL and Xinte and all the other companies which I mentioned you, because they're waiting for us, actually. And let's build a huge factory to supply the whole world, okay? So the question is, Once it happens, I mean, there's a first step, then everything will be with collaboration with the University of Tirana, Academy of Sciences, University of Pristina, and other Kosovo, and everybody else. So it's a lot of work to do. I mean, this is just a start.
Other questions or discussions? If not, just one small question regarding the Czochralski method. Are you using a specific crystallographic direction for the crystal seed you use to grow up crystal?
For the crystal seed, yeah, crystal seeds are basically, you just start on the crystal somehow, and then you cut it, it's very thin.
But does it is it important, the crystallographic direction of the seed?
Crystallographic direction, yes, it's important. We use either 111 or 110, but it's important just to have one direction, but yeah.
Okay, thank you.
Thank you. Anything else?
So I would like to thank once more Dr. Chitra. And in order to foster the collaboration between the industry and the nano-art groups, I have the pleasure now to invite here the second speaker, which will be Professor Dr. Sopai from the Department of Chemistry, Faculty of Natural Sciences and Mathematics, University of Pristina, with the topic electrochemical degradation of phenylurea herbicides with an electrode system modified with graphene oxide nanoparticles.
Përshëndetje për të gjithë, atëherë. Sorry. So, hello everybody. We have been working now on a subject concerning pollution, relatively new technology, but with some improvements or attempts to make some improvements, and it involves carbonous materials, namely in this case here, graphite fiber, which we use as an anode to incinerate organic pollutants. Now, organic pollutants are of many types, but we happen to just select a base of pesticides since they are very, very common in the use in the agriculture and unfortunately in the everyday life in the surface waters. So the method consists in an electrochemical system, electrolytic system more precisely, which has a cathode and an anode, and the cathode produces hydrogen peroxide, which is known to be an oxidant, but at low concentration, it is not very efficient. But when a catalyst, a proper catalyst, is added, it can multiply its oxidation power by generating hydroxyl radicals, which further destroy organic pollutants. Now, in the other hand, the anode also does some contribution in the pollutants degradation by generating also hydroxyl radicals from the water discharge on the anode. And after the degradation, there are generated byproducts, and if the process continues sufficiently long, they are completely transformed to minerals which do not pose any threat for the living organisms. Here is an example of the working system with the graphite fiber as an anode, and here is the degradation of model pollutant, which is bromphenol blue, and it can be seen here in this figure that with the time of the treatment, the peak of the absorbance decreases, and by the by 1 hour treatment, it is completed. Its destruction is completed. And the concentration trends are presented here. 4 different electrolyte concentrations. Now, graphite fiber, as any carbonous material, is known to be very fragile to potentials. It is oxidized itself and degraded, so it is not seen as a very suitable material to be used as an anode. However, during its degradation, it can perform quite well in the destruction of organic pollutants. Moreover, we can see from these SEM images that it doesn't undergo such a high destruction, structural destruction itself. Here is a little bigger piece of the material photographed from a higher, longer distance. These are the fibers at the non-used material. This is a magnification. We see clean rods. And here is the material after being submitted to a very high potential, rather high indeed. This was applied an 8-volt potential, which is for electrochemical systems is quite high. And we can see the degradation of the material itself. While it degraded the organic pollutant, it got destructed itself also. Well, we can see here there is some peeling, which we expect might be some graphene or oxidized graphene sheets, and also transversal lacerations and some bigger chunks. There are different types of physical degradation of the materials. However, even being transformed in this type of structure, it still performs the degradation process of the organics. And that is the material, the macroscopic form of the material, which is used as the anode. Further, during the degradation process, to know if the substance has been degraded, chemical analysis is required. Normally, it is chromatography or other techniques used to follow the trend of the concentration of the pollutant. But lately, relatively lately, electrochemical methods has been proposed to monitor the concentration of the degraded pollutant. Now, this is somewhat limited because it can be applied only to the compounds which are electrochemically active at least in the window of the water oxidation potential. And here we have performed the degradation of phenylurea on the anode, or graphite fiber anode, and the remaining molecules are expected to react in the screen printed carbon sensor, which will give an electrochemical signal, which shows here in this figure. Now this bolded line shows the initial concentration, initial line of the phenylurea, and the dotted lines show the electrochemical signal during the time of the electrolysis of phenylurea. And it is clearly can be seen that this peak diminishes significantly until it vanishes completely after about 1 hour of treatment. And we have also this byproducts generation, which also starts to be degraded itself. And if the electrolysis continues further, we expect this to disappear also. Now, this is the core, the two main points of the project, which has been largely completed, but there are some parts that remain still to be completed during this year. We are expecting some material to work with. And meanwhile, with the already disposing materials, we have tried to work further and characterize further the graphite fiber anode. We have tested its stability in different potentials. Now, at 1 volt potential, during time, we can see at the beginning we have a current intensity about 60 microampere in a sulfate sodium solution. And we can see that it decreases to 20 microampere and it stabilizes. And those little peaks are just, we expect these are just hydrogen or oxygen bubbles, water discharge at the anode, or oxygen bubbles released. The situation changes when higher potentials are applied. You can see here at 4 volts and especially at 8 volts, we see those sharp peaks which we still, for now, relate to the oxygen release in the anode surface, in the graphite fiber. But we have some larger peaks, broader peaks, which we associate with structural changes on the graphite fiber structure. And this makes the current fluctuate during the process. And this also tells something about what happens with the anode surface during the degradation of the pollutant. And finally, we have performed another test with Tafel slope here. We can see that the exchange current, I0, shifts a little bit in the left, which means higher potentials are required for the electrochemical processes to occur. And this happens because we expect that at the surface, at high potentials, the carbon surface is oxidized and become less conductive. That requires higher potential to drive the electrochemical process. And also here we have an increase of the anodic part of the curve, and it stabilizes after some time, which also tells that although the surface deteriorates during time, during repeated use, it doesn't deteriorate linearly or even exponentially, rather logarithmically, we would say. It stabilizes at some point, and it can continue to be used. Of course, unless some very high potentials are applied, and that it will burn out completely. So this is about characterization a little bit, and we can say that graphite fiber can be successfully be used for organic pollutants degradation. We can also monitor the pollutants electrochemically during the treatment, and so on. And thank you very much.
Thank you very much, Professor Sopay, for the very nice and informative talk. And now I open the floor for questions and discussions.
Yeah. Yes.
Do you have information about the byproducts that are formed from this electrochemical degradation?
Now, about the byproducts, this is a real serious issue. We only can say there are byproducts, and we can also fortunately say that we have destroyed byproducts when analyzing it electrochemically, because we saw a new peak which comes from the byproducts, and it also starts to diminish, which means it is being destroyed. Now, I am sure that it is not the only byproduct, but it is the only one probably that gives us an electrochemical signal, or maybe 2 or 3 which give similar, which are overlapped with each other. but electrochemically, we can't say which is where. Now, for that purpose, more advanced techniques are required, such as GCMS or LCMS. So chromatography definitely is needed for that.
Thank you. Thank you. Any other questions? Yes.
Thank you very much for the very interesting presentation. I just wanted to let the audience know that what you are developing, in addition to many other applications, is with interest for the decentralized control and destruction of pollutants in water. And here, I think, at least I have met one colleague from interested in water filtration and treatment. So I think maybe a good opportunity also to collaborate with industries that are interested to your technology. So this is one of the objectives we have also in this meeting. So probably
Yes.
during the coffee break, you may discuss that.
Yeah,
I would like
I guess so, because during filtrations, many chemicals behave differently. Sometimes maybe to achieve better filtration, you need to transform molecules, so the filtration is achieved in a more efficient way. So it can be a pretreatment, this technique, to improve some combinations.
it can be combined, hybrid technology, but also it can be independent, depending on the application.
Yes.
Because as I said, for example, if you aim to apply this technology even at the home level, where people would like to control what they are having as waste, then you know whatever you have there. So you may apply this to destroy your the pollutants and then ensure that you pour the water in a controlled way.
Yeah, so yes, thank you.
Thank you once again, Professor Soppen. Okay, another question.
Thank you very much, and I think it's a great presentation. Of course, I think 90% of things just go over my head, but that's okay. I learned something. In this technology, have you thought about, say, is it a viable commercially? Is it possible to take it to the commercial level?
Right now, this technology, this electrochemical oxidation of organic pollutants, has started to be developed scientifically about 2000s, maybe 90s a little bit, just some indications, but mostly in 2000 and after 2000s. So I don't think it has reached that level to be applied industrially. There is potential. There are data that indicate that it can be applied. And I know there are some semi-pilot tests performed, and a professor from Spain, I think he said that they had already applied in large scale, maybe some hundreds or thousands of liters of the polluted water, using some different other anodes, because there are even better anodes than this. This is not the best, but it is the cheapest. That's why it is interesting to study it. But since those examples, I haven't seen that it has started to be applied commercially. Maybe someone didn't see it, not yet fit enough to try to apply it industrially. But it is particularly beneficial when it is combined with solar or windmill energy.
Thank you very much.
Thanks.
If you would like to make some trials, some tests in industrial scale or pilot scale, our company would be very, very happy and available for you to start doing some kind of
thank you very much. That is very helpful.
We are very interested on this technology to clean the waters, especially industrial waters with organic.
Yes, it is more. This technology is more suited for micropollutants. Thank you very much.
Once again, thank you very much for the presentation. And now I have the pleasure to invite here the CEO of Insect Intel, which will be Endri Dascali, with the topic Intelligent Insect Monitoring and Early Prevention of Damage in Agriculture through the Use of Artificial Intelligence.
Well, good morning, everyone. My name is Andri. I have a Master of Science in Computer Engineering, and I'm the founder and CEO of Shkencave. First, I would like to thank the Academy of Science of Albania and the NanoAlp team for inviting me, and it's a privilege for us to be here today and present Shkencave and share our vision for how intelligence, artificial intelligence, and future sensing technologies can contribute to more sustainable agriculture. Okay. The challenge. Agriculture faces a persistent challenge: insect pests. Globally, pests destroy 30 to 40% of crops each year, draining $220 billion from the food industry. 20 million tons of pesticides are used, 80% of it is wasted. But the problem is not only the damage caused by pests. The real problem is that growers often discover infestations after the damage has already begun. And current monitoring approaches are labor-intensive, expensive, and difficult to scale. As a result, interventions are frequently reactive rather than preventive. Today, pest monitoring still relies heavily on manual scouting. Agronomists or farmers walk through fields, inspect traps, count insects, and record observations. This process has three major limitations. First, it's labor-intensive. Second, observations occur only periodically. And third, the resulting data is insufficient for reliable forecasting. Biological systems change rapidly, while monitoring remains slow. Without continuous data collection, predicting outbreaks before they occur becomes extremely difficult. At Shkencave, we are building a fully automated monitoring pipeline. The process begins with insect capturing using smart trapping methods. Integrated imaging hardware periodically captures high-resolution images of specimens, and those images are transmitted to an AI-powered analysis system. The AI identifies space, counts populations, and detects unusual trends. The results are then delivered through a dashboard where growers or agronomists can monitor pest activity in real time. Every captured insect becomes a digital data point. The system consists of three main components. First, image acquisition. Waterproofing imaging systems collect data continuously in field conditions. And second, specifies classifications. Machine learning models identify pest species from captured image. And then, anomaly detection. Population changes are analyzed over time to identify unusual activity that may indicate the beginning of an outbreak. Our objective is not only identification. Our objective is transforming biological observations into actionable intelligence. Okay. Today, we have developed a working prototype on core data infrastructure. We have built the hardware platform, established image processing pipelines, and developed species identification capabilities for key agricultural pests. Our next step is field deployment and large-scale data collection. This phase is practically important because agricultural AI systems improve as they accumulate real-world observations from diverse environments and crop systems. What's coming next? This is our roadmap. It consists of 4 phases. The first phase focuses on validation and infrastructure refinement. The second phase involves field pilots and data acquisition. The third phase introduces nano-enabling sensing and environmental intelligence capabilities. The fourth phase aims to predictive outbreak and forecasting and broader deployment. The long-term goal is to move from simple monitoring towards predictive agricultural intelligence. Today, our platform primarily sees insects through image systems. Tomorrow, we believe it can also sense the environment around them. Many insects communicate through pheromones and volatile organic compounds. Plants under stress also release distinct chemical signature before visible symptoms appear. Future nano-enabled sensors may allow detection of these signals at extremely low concentrations. This will create entirely new possibilities. Instead of detecting pests after they arrive, we may eventually detect biological signals that indicate their presence before visible evidence appears. We are particularly interested in 4 research directions: nano-enabled sensing, integrating nanomaterial-based sensors for ultra-sensitive detection of pest presence at molecular levels; VOC, volatile organic compounds detection, volatilome profiling to detect plant stress signatures and pest activities before viral symptoms appear, predictive outbreaking modeling, machine learning models that forecast infestation risks, and environmental intelligence, using weather, soil, and phenology data to contextualize pest pressure and improve model accuracy. Together, these technologies could transform agriculture monitoring from visual observation into molecular level intelligence. This workshop is about science meeting industry. For that reason, I would like to emphasize that Insect Intel is not only a technology company. It's also a platform for interdisciplinary research. We are interested in collaborations with researchers working on nanomaterials, group developing biosensors, artificial intelligence specialists, agricultural scientists, environmental monitoring experts, and we believe that next generation of precision agriculture solution will emerge from collaboration across these disciplines. Many of the challenges ahead cannot be solved by a single field alone. Insect Intel vision is simple: to create a future where agriculture decisions are based on continuous real-time intelligence rather than periodic observations. By combining AI, sensing technologies, environmental data, and future nanotechnology innovations, we hope to help farmers reduce crop loss, optimize interventions, and improve sustainability. Thank you for your attention.
Thank you very much, Mr. Dascali, for the very nice and informative talk. And now is the time for questions.
For you, I am Magdalena Zara from Agricultural University of Tirana. My presentation should be next to you, and it is in agriculture, but not in pest, in pathogen, especially for viruses. Let's say some insects are main vector of viruses. And now with climate change, some of them, for example, thrips are present even in early spring, that it is not usual. And I have a question, or let's say invitation for collaboration. Did you have any trial in the field with this, or just with computer?
Right now we have.
And the second one, if you want to collaborate, we are open for this.
Yeah, for sure. Well, thank you, and I'm really looking forward for your presentation because I see the agenda. And yeah, we have a few devices deployed across 3 farms in Albania. And right now, what we are doing, we are using pheromones and the bright colors. We lure the pests in, the dangerous ones. And once then the pests are in, they get stuck there. And there is the camera on top of the device that take the images. And we also do further analysis using AI. We have an algorithm. We have our own AI algorithms that we have trained. And as we speak, someone is working and training the algorithm to identify more species. Right now, we can do only pest identification, but also knowing or having access to a data set saying that these types of pests can outbreak this specific virus. We can integrate together all the data that we have, and we can say to farmers that this type of pest is present in your farm, and careful, or you have to do like X, Y, Z in order to proactively protect the crops. Right now, we are not doing, we don't have yet the access on the data set, for example, to all the viruses that are out there, but we can say that we also do pest counting, which is very important because based on the number of pests that are present in a specific area, we can we can forecast how long does it take for the farm to be under attack. It's a known fact that if number of pests of the same species is more than 7 or 8, it means that that farm will be under attack in the next 24 hours. So we do have some data, but not, we are looking forward to it. We want to collaborate with Plantix, which is a German company, and they have a lot of data, but they mostly do crop analysis, meaning that someone taking a snapshot or a picture to a leaf or to a fruit, and then they can upload the image. It's not an automatic process. Someone has to go there to do it. So they upload the image, and then the system says that this crop has 1, 2, 3 problems, or if a virus is out there or something like that. Yeah, or a bacteria. Yeah.
Thank you once again. Another question?
And so I just, how long does it take to detect it? It's like you have to keep it for a few hours or it's instant or what? How does it?
The device is a standalone device. It has an internal battery and also solar panels that can charge the battery. It can go on forever in terms of you just need to deploy it somewhere. The setup is under 10 minutes and can cover up to 1 hectare. And it doesn't need constant maintenance. It doesn't need someone to go there and to check it. It's an autonomous. It's a real time. You just need someone going once and then, maybe one in 2 months or 1 in 3 months, just to replace the sticky paper. And that's it. It's a 24/7 system. It works on and on. It works forever. And it is also alert based, meaning that you don't have to sit in front of a dashboard or a screen to check the traps. As soon as something happens, it will immediately identify it and notify it, sending not just alerts, but also actionable data-driven insights, saying that you have to do X, Y, Z in order to be there and to protect the crops, like proactively protect the crops.
So it's a continuous process.
Yeah, it's a continuous process.
Thank you very much for this presentation and for this contribution. We are also in the field of agriculture. We are serving smart fertilizers, let's say, which are contributing importantly also in a reduction of illness to the plants and the reduction of needs for protection. But anyhow, we have farmers which need pest protection, and we would be very happy to be partners and to collaborate with you. We have over 150 farms that we are following daily with our researchers on the field. And being that we are committed in the organic farming and increasing the production, this is exactly what can which can fill, let's say, the gap that we have on this sector. We are already working and collaborating successfully with other digital guys, digital companies, innovators, which are involved in digital measuring of land properties and other things. So by creating this cooperation, I think that we can offer complete service, let's say, to the farmers for a smart agriculture. So
yeah,
after this meeting,
yes, definitely,
let's discuss on it.
Thanks a lot. Yeah, I know your work, and I'm a fan of your work. So we are connected in LinkedIn, and I follow all the activities that you are doing, and thank you very much for that.
This is perfect. This is perfect. This fits perfect with our objectives, and we can cooperate with our research and development team, part of them which are here.
Thanks a lot. Thanks a lot.
Maybe one last question regarding the connectivity of this device. In order to have, let's say, updated information, do you need a stable Wi-Fi or something like that?
Right now we are using LTE, and in Albania, to be honest, Albania is not our primary market, so we have developed the entire system to go abroad, and we have a few contacts, and we're going to go in Europe and also in California, in the United States. And there, the LTE is already covered. The rural environments are already connected. But also in Albania, we've seen that if the mobile works, if your mobile phone works there, we have signal and we can transmit data. In the areas that are very remote, we are using LoRaWAN, which is a technology developed specifically for the IoT devices. So it can send the signal more than 1 kilometer or maybe more. And also in some other areas, we have created this mesh network that we just need one server, which is connected to the internet. And all the others, they can be communicate wirelessly to this server, and they can transmit the data to him. And from there, we can upload them for all the field to our server.
Thank you. Thank you so much.
Thanks.
And now there is another presentation from the agriculture area, which will be advancing agriculture through nanotechnology, enhanced diagnostic and management of plant pathogens. And I have the pleasure to invite here Professor Dr. Magdalena Zara, which is the project coordinator.
So my presentation is in frame of the project, Ignite project, that financed from Academy of Science. And it is connected with agriculture again, but it's more specific and applied. I am coordinator of this project, and also we have partner from Siam Bari, Professor Edbanio, and no. Yeah, say so. Still Tatimin. Still for the. Безост. Це дефекту собою, а це дров, а то вони не вчили. Ага. Дров вони не вчили. Дали мостом. Це я потім пишу. А? Até não vai que tu já estás sofres. Ali para a Sorry for this. Also we are in collaboration with Siam Bari, Professor Tofik Edbanio, who is also co-group leader, and all our team, Orges, Clevis, and Professor Mercury. In meantime, we collaborated with partner from Italy and from CNR, Centro Nazionale di Ricerca in Bari, and also University of Bari. Albanian group is from NanoAlb, who is Clary Jagil. Objective of our project are connected with identification of emergency pathogen that affect green vegetables in greenhouse, and also rapid detection of this pathogen with nanopore sequencing technology, MinION, and evaluation efficacy of this technology connected with existing one, Sanger and high throughput sequencing technology. The last but not least is the objective that performed from our group is feasibility using of smart pesticide and nanofertilizer. In our project, we collaborated with two companies. One of them is Ridacom for laboratory purposes, and the other is CropTech Albania, which is a company that imports nanofertilizer. Some data about the surface of greenhouse in Albania and also the crops are referred from Instat Albania and also FAO. I will discuss about emergency pathogen, which are these pathogen. We have two kinds of pathogen, quarantine pathogen and emergency pathogen. Quarantine pathogen are the pathogen that are not detected in country, but they have a high economical impact. But nowadays, also we are discussing about emergency pathogen.
These pathogens maybe are not new, but they appear again and cause the economical impact. Some of them that we are in focus in our study are fungi and viruses, for example, Fusarium, Neopes pilotiopsis, and some viruses, tomato brown rugose virus, which have been in focus in our study, but we find also some new viruses. What are the contributing factor of this kind of pathogen? Climate change, as I mentioned before, is a really problem in agriculture because appear the new pathogen, and this pathogen we can find in different time that we didn't expect them. And as I mentioned before, for example, some insects are really important vectors. Let's say a couple days before we have been in Skutari, and we saw in a greenhouse that it is completely damaged the pepper from one virus, which will be reported from our group soon. And to manage this pathogen, integrated pest management, IPM, is in focus of agriculture in all Europe and all world. But let's say integrated pest management is not applied in significantly way in Albania. So it is important to apply sanitation practice and also to find resistant varieties. Here you have some picture with the symptoms from different greenhouse in Albania. And our methodology of work consists in field survey, laboratory analysis, and also in data analysis. Next generation sequencing technology is Sanger technology, reads one DNA fragment. In this time, nowadays, they are really important to apply some new technology. Let's say Illumina and Oxford nanopore technology, which is applied for the first time in Albania. Nanopore technology is the third generation sequencing that use nanopore protein to detect nucleic acid sequence of DNA molecule. The DNA passing through nanopore changing its current and depending on shape, size, and length of DNA sequencing. Oxford is a university that produce this equipment, and we, in frame of this project, we buy the mean ion equipment. We buy from, our collaboration with Ridacom is that we buy this device exactly from this company, and Besar Aydini is here, the representative of company that offer this and also offer some assistance. This company is in market, is new in market, have 3 years, and we have 2 years that we are collaborate together. They offer molecular biology, microbiology, biotechnology, molecular diagnosis, scientific research, and food safety. Also, this strategic partnership and international network of this company, as I mentioned, in our group, with our group, is just focused in Oxford nanopore technology. And why Ridacom? This slide are prepared by company. It is a global technology leader, scientific expertise, technical support, and also innovation driven approach. How was our work? We start with sample preparation, collection biological material, and after that we extract DNA or RNA, depend, for example, RNA for viruses and DNA for fungi. This is the theme and all the steps that we follow during the extraction and preparation to use this mean ion sequencing. The company till now offer 2 kind of kits. One of them is normal kit, so it's just sequencing with 1 run, and the other is barcoding kit. We can, this is a multiplex read, multiplex run, and we need the demultiplex reader to distinguish. For example, here you have different viruses. For example, The first one is a virus, the second one is a fungi, and the third one can be bacterium. So with one run, you can detect or you can sequencing different pathogen. This is the kit and the job with mean ion. It is a little bit complicated, so we spend a lot of time to understand how it works and to understand how we can read the sequencing. The company offers also MinKnown, which is the software for connection between device and computer for first reading. But to have the, let's say, a bioinformatic or exact reading, we need the Genius program, which offer from Siam Bari for the moment. And the results and discussion during our job, we isolated different fungi, which are Fusarium oxysporium, Neopisthalothiopsis, Alternaria, Fusarium triticum. All of them we register in National NCBI, National Gene Bank in US. There are some, the strawberry are from Kafarai in Fier. You can see in the picture of the problems that farmers face with this phenomenon, which destroy almost, let's say, a main part of their production if they didn't take care. And here is a fragment of the job. This is the equipment, is portable equipment. And in this case, we use in laboratory condition. Viruses that we detecting in mean ion, but not only in mean ion. We done, let's say, Sanger sequencing and also NGS sequencing because it's a validation process. It's the first time that we use this for tomato brown rugose fruit virus, southern tomato virus, which is the first report in Albania, and also tobacco vein clone virus, which also is first report in Albania. All the viruses are detected in tomato. Here we are some comparison. You can pass fast. And I will stop a little bit here in zucchini. It is a phenomenon that in zucchini, it is a virus, watermelon mosaic virus. So this virus belongs to watermelon, but it jumped to zucchini. And in the greenhouse in Duros that we find this, almost 37% of the production is completely destroyed because if you see this kind of fruit in the market, you don't buy it. And why the sequences is important? The sequences is important because we need to know in phylogenetic tree, we need to know the origin, let's say, of isolate. For example, this phylogenetic tree is, we can read that our strain of the virus, our isolation, is similar with Czech Republic and Spain. So we need to collaborate with the farmers to ask them about the seeds and to find if these seeds are exactly from Spain and to see the resistance gene. Because to advise the farmers, it's important to buy the seeds or the seedlings that are resistant from different viruses. This is important because the production can destroy completely from viruses. Viruses and some bacteria can't control with pesticide. This is a watermelon mosaic virus in the NCBI, National Library, National Center for Biotechnology and Information. And according to our experience, which is not, let's say, long experience, but 2 years, we work in 2 years, with mean ion, we sequencing fungi and also viruses. But for viruses, we are more confident than in fungi. This result is because the viruses, the fungi are big molecule. and need more and more investigation to arrive, let's say, the best results. And the last part of our project is just feasibility using smart pesticides to control some of the disease and their vectors and nanofertilizer to reduce impact and their use on health and environment. Let's say till now in Albania, we didn't have any nanopesticide register or the, let's say, trial for using till now. Nanopesticide refers to the type of pesticide that incorporate nanotechnology, especially nanoparticle, to enhance effectivity of pest control. But nanopesticides, let's say, have a lot of advantage, but if we compare with normal pesticide, but we still are not very confident with the toxicity, their toxicity and their exposure in environment and in human health. Here are pros and cons about nanopesticide. Nanopesticides are two type of formulation, nanocarrier and active ingredient size, change size. Nanocarrier load or absorption active ingredient, which means add active ingredient in this particle, and they can formulate as nanofungicide, nanoinsecticide, nanoherbicide. The key of differences is from protectant and carrier is that the active ingredients that act upon contact, in carrier active ingredients that are gradually released. There are some more formulation, and I will stop here to see, I mentioned that we didn't have any nanopesticide, but if you see some global market and the forecast for 2033, you can see this production or the market will grow so fast. And what is important about legislation, in our legislation, we didn't mention about nothing about nanopesticide, nanofertilizer, or nanomaterial. But United States is the first that regulated nanopesticide under FIFRA, Federal Act for Insecticide and Fungicide. Also, European Union are regulated through EFSA, European Food Safety Authority, and ECHA, European Chemical Agency. They oversee the regulation of nanopesticide. Also, EU regulation, it is applied nanomaterial, when applied nanomaterial, including also nanopesticide, and other countries have their legislation, for example, Australia, Canada, and Japan. And as a conclusion, smart pesticides represent a significant advance in agriculture pest control by integrated cutting-edge technology such as nanotechnology. The ongoing development and absorption of smart pesticides can lead to healthier crop, safer food supply, and more sustainable agriculture ecosystem. And the last thing that I will mention and will follow, I think, by Mr. Zusi is fertilizer. About nanofertilizer, I will finish soon. About the nanofertilizer, you can ask soon about nanofertilizer, and I will mention just the company that offer in Albania and some tests they have done, and these are the products that are tested or registered or to be tested or under trial field, and the trial field have done in generally abroad, but some of them are done in Albania, especially in strawberry. In tomato, and the next slide in strawberry. They use nanocer with different composition of macronutrient. And as a conclusion, they said that 2% of production is increased and longer fruit and some other benefits about this use. In frame of this project, we have published already submit in Journal of Academy of Science, and we have three more papers that we'll submit with impact factor. And I want to thank a lot of thanks about my team and Professor Elbeanio and all the team that contributed in this study, especially Claudia and his team. Thank you very much.
Thank you very much, Magda, for the very nice presentation and for your contribution in the area of nanotechnology. And now I open the floor for question and discussion.
Thanks a lot for your presentation. I want to know for this nano ion,
Minion, you mean?
Minion. It's a qualitative or quantitative detection of DNA.
Okay, this equipment is just for sequencing. And if you take the sequence, this sequence you can, let's say, proceed in Genius or in different bioinformatical program and take the short one. And after that, you can compare in NCBI. You can do the blast reading in NCBI, and you can distinguish the Genius and, let's say, the species. But it is a fast detection, because if you don't know the pathogen, you need to do NGS. To do NGS, it costs at least 500 euros. And you can take the response after, let's say, 1 month, because depend the company that will do NGS. And after that, you need to proceed with, let's say, special program in bioinformatics as Genius or another program to find the sequencing, to let's say, to know the Genius and the species. And after that, you will proceed with PCR and with Sanger. And step by step is a long way. But the farmer can't wait you after 2 months for response. They need a response, for example, for this pathogen or viruses, especially viruses. Our focus are viruses, because as I saw during the job, the fungi are more difficult. It's not the perfect solution, Minion, but for viruses is another thing.
Another question?
Thank you very much, Magda, for the presentation. Just a curiosity about these nanofertilizers. You mentioned that safety is one of the issues still under study, right? But you showed at the end that there is like a 2% increase of efficiency, but is there any data about any study in relation to safety? Because efficiency is okay, but I think at the same time, studying the safety should be very important, yes, right?
Good question. Let's say, I will emphasize to be safety, especially for nanopesticide, that nanofertilizer, but depends, because in generally nanofertilizer, safety is more important for environment, for example, for soil and for infiltration in water. It is important also, but for focus is environment. We didn't have any study for this. And our feasibility and the paper that we are working, there are connection about the amount that we use and some modeling, some theoretical modeling to put the data and to see because it's a very good question, especially for environment. But for nanopesticide, that the health is toxicity and the other problem with the health should be studied. Maybe this is the reason. Let's say two last year, I work a lot of with negotiation process in chapter 27 and subchapter chemicals. And we didn't mention, or I insist to mention a little bit nanomaterial, especially nanopesticide and nanobiocide, because for nanobiocide can be more safety than normal biocide and more effective. But let's say in Albania, we didn't have any legislation. in directive, in regulation 527 in 2012 of, let's say, biocide product, is mentioned just one time, nanomaterial. We are in the first step, let's say.
Another question? If not, I would like to thank once more my colleague, Professor Zara, and invite here the last speaker for this session, which will be Alban Zusi and Mr. Hitendra Mehta, with the talk from bioproducts to biopharmaceuticals.
Thank you very much for this invitation. We are very honored to be in this aula today. We will be presented as an industry. You will give us some tolerance, let's say, to be presented from 3 speakers. We will be within the time line to present, but we are going here to present some achievements that we have and what we aim. We are going to present some Albanian typical problems regarding enhancing the scientific research and the industrial application. This is our main aim. And after that, at the end, I will speak about some regulations in the level of let's say, policies that can enhance more the cooperation and the science in application technologies, industries, and being fruitful for the economy and for people. So first, I'm giving the floor to Hitendra Mehta, a researcher of 40 years, researcher in the biggest API pharmaceutical company in America, SPL. Floor to you.
Thanks, Robert. Well, I prepared my presentation in Albanian. Now I'm disappointed. But anyway, I'm Hitendra Mehta, and just give you some. I'm born and brought up in India, and since last almost nearly 50 years, I'm in the United States. There are some of my educational backgrounds. After my pharmacy degree from India, I went to US and did my master's and MBAs, and I get some certifications. How many people heard about Six Sigma? No one? You heard about Six Sigma. What do you think about it? I think it's a great concept. I think every university should adopt to that because it's specifically for the PhD students. Anyway, so that's my background. I was in the US. I have over 40 years of experience in pharmaceutical API manufacturing. And what I realized is that how come there is no pharmaceutical manufacturers sector in Albania? Why there's Mr. Juicy is the first one who started the pharmaceutical manufacturing. So I'm always wondering why not in Albania? What is stopping that? And that's interesting. Anybody think about that? Okay. All right, and go back to myself now. So yes, I have thoughts. I'm also the professor in the one of the universities in the US, and I taught several business classes that includes operations management and business statistics and all these classes. One thing I've done also is, anybody heard about the Malcolm Bridge National Quality Awards? That is a US based. That's a very high level of award that any business can have. It's a nationwide, and I was an examiner for that that's award. So it was a great honor and help to be a part of it. Now, one question is that I think the pharmaceutical business is not developed, or that sector is lacking in Albania is because of I think Albania has a small population. And it's not even worth for a business to spend so much money for such a small population. But anybody heard about the CDMOs? The CDMO is basically the contract development and manufacturing organization. And what they do is in CDMO is you can have a facility, you can have equipment, you have high profile employees with the more experience. And the companies come in there and ask this CDMO to develop the process or even large scale. Just give you an example that when I was in the US in my previous life, we had a company come to us and ask us to develop the extraction of an active molecule from the pituitary gland. And this company had hardly 10 people working there because that's where the model. They don't want to set up they don't want to buy the buildings and equipment and everything. They just want to do it on their own. So we become a CDMO for them. We developed the process, took it to the commercial scale, and now it's over $25 million business. So that's kind of, I'm thinking about, say, Albania can be in that direction, not having a pharmaceutical company, but have a CDMO. And that's what I proposed to Mr. Zusi about that. Say, why don't we create a CDMO? We have a university with the collaboration with the university. We have a high-profile people there. We can get the equipment and knowledge, and we can create a CDMO, and we can attract the other investors from the globally to develop this process. And that's, of course, for CDMO, we would need the experienced scientists, advanced R&D, which we have a university right here in a collaboration, we can do that. Strong university and research collaboration, technology transfer partners, and also international expertise. So that's about me. Thank you very much.
Okay, the second tenor. Okay, the problem is not to produce. The problem is the way which you can produce. Our company today, it's 100% circulated economy. What does it mean? Today, it's emergency to recirculate it, everything it's possible. And it's an Italian song, dal diamante non nasce niente, ma dall'etam nascono i fiori. In this case, we produce a nano fertilizer, which you said. We are producing a lot of materials for the biocarburant, and the most important things is for the pharmacy. For the pharmacy, we are producing many things. It's very difficult to work with the biological products because it's difficult to sequence that, to separate, to define one of them. And if we see, for example, the family of GAC, which we are working, are very similar. Each other are very similar. If you change little bit the technology, you lose your product, and it's not possible to take what you want. And in our case, we are producing different type of this GAC. It's glycosaminoglycan for the pharmaceutical. We are the first company, I think it's the first time in Albania to produce API. And we are producing API, and we are connected with different companies in in all of the world. The problem is the connection to have the knowledge people to the connection between the university, the academy, and the industry. For this needed some different connection, and pilot scales to develop them and to go in the industrial scales. Now, because our target, our GAC, it's very important for the pharmaceutical. It's very important with like nanotechnology, because they are very interesting to used as a transporter, as a medical transporter in the tissues. Are many articles which are created the scaffold with the GAC to use as a transporter in the tissue. This is a very interesting thing because we see the drug as seeds, but now the technologies change in the modify the life of the cells. And in this case, with the GAG, we can modify the life of the cells to select to kill or to leave the cells in base of our duty. Okay, now I can leave our.
Okay, that is not so much important. That's a presentation of me. I am an entrepreneur which has understood, let's say, that to be competitive in this world and to be at the same time contributors, because the entrepreneurs, first of all, should consider themselves as a contributors for the society. But to be a good contributors, you have to be also based on the scientific research and not just work by muscles, but work by head. So in that regard, we have created a company which we are very proud to say that already we have a nucleus of 4 researchers, PhD professors, international researchers. We have a laboratory which in 2-3 months will be maybe one of the most equipped for chemistry, pharmaceuticals, especially for applicable motives. And we want to work also in promoting this kind of cooperation between science, academy, government, and the industry. Everybody knows the numbers of investment that we are doing in the science and the investment that are done in Europe or in innovative countries like South Korea and things like that. And I would like to bring only, we have a presentation there, but Ilya, you can help me to go through, but I would like to bring here only two examples and to jump in the conclusions. I met Hitendra for the first time in July 24. In August 24, we started cooperation to each other. It was only 1 month needed. And for sure has been a very good choice for our company. We have developed, Ilir is one of the best chemists that I have known in Albania, but Ilir said that Hitendra was a university for me and for all the other teams. Again, In August 24, we started this cooperation. In September, one partner of ours from South Korea, which was the first one to transfer us the technology of pharmaceutical, came to see what we were doing with him, what were the innovations. And within 1 month that he came back in South Korea, he managed to have from his government 300,000 euro to support the new technologies that were introduced from this man. So immediately, the government there supported the research, being that he presented to them that with a new technology that was developed from the biggest American company, they can reduce the cost and they can have another benefits. So we have to follow these models. We have to go ahead. The motives that they give to him the money were that they said that this technology, this transfer, this 300,000 euro will serve to bring millions of euro to the farmers of South Korea, which will sell for a higher price their mucosa, which after that will be transformed in heparin and other products. So in this regard, I would say we have to work together to have a new model of doing. Okay, these are some figures. Okay, Ilir, just leave 1 moment, the first slide. The first slide. Yes. One of the contributions that we are giving is regarding the circular economy. Proudly, I can say that we are the #1 industrial company in Western Balkan, which is fully circular. We are transforming 10,000 tons of animal byproducts of threats for the environment in 3,000 tons of valuable products for the economy. Our aim is within 5 years, 3 to 5 years, to transform 45,000 waste animal byproducts into 15,000 tons of valuable products for the food sector, for the pharmaceutical sector, and for the feeding sector, and reducing them the costs. And we can say, again, proudly, that we have increased by 25 to 30% the rendiments of agriculture farmers by using these products. We have in our team, we are the first biopharmaceutical API in Western Balkan, as far as we know. We have 3 PhDs in our researching team, and we have this advanced laboratory. Ilir, can you pass? Yes. What we suggest, what we propose, to create the first model of SDMO in partnership with industry, academy, and government or investors. We have all the knowledge to be a developer of processes for the other industries which have problems or which they want to develop. We have achieved this level of expertise to give them or to design the models of them to solve their problems or to increase and to be more competitive. For that, we need to present our model, what are the investments for the laboratory scale research and pilot scale, and after that, the industrial scale can be done from companies that want or from our company, which have already a lot of industrial equipment which can transform almost any kind of animal byproducts in valuable products. We think that it's time to have a new law on the research. Now the research should not be property of only universities. The research should be object and subject of the whole industry. Academy, which make research which cannot be applicable, I think that also for academics itself, it's not so satisfying. So also for the academics will be very satisfying, and we think that this will be also a mutual beneficial process. So the industry will benefit from them. I say it 100%. We will not reach what we have reached if we didn't have very high experts in our company with very good knowledges on chemistry, in pharmaceutical, in agronomy, and in other fields that we have. For sure, we could not achieve and arrive until here without their knowledges. But also then, I am sure that they are increasing and they can increase more, and they can transfer better their knowledges to the young generation. And by creating some centers like this, which we preview to hire at least 15, 20 talented young people, we can start to create also a nucleus of talented people which stays here, do not go outside to develop themselves and to find themselves. And why not to bring also talented from outside to work here and to contribute here, as we have done with Mr. Mehta. We are not saying something new. Just another example from the South Korea, where we have very good partnership with them. Our partners, which is at the meantime steps ahead the others. Okay. Thank you.
Thank you very much for the nice presentation. So if there are questions.
Thank you very much for the very nice presentation, and congratulations for what your company is doing. As I saw here also, you are, the objective is to be the leader in the Western Balkans, right? So this is something fantastic. As you mentioned, the collaboration between industry and the academy is very, very important. And we are aware of this, and for scientists it's very, very important, not only in Albania, but all over the world, because what we are doing in academia should go to the society, because we are financed by public funding and we want the benefit to go to the society. But at the same time, academia researchers work also in basic research, which is also very important, and also not only here, but also in EU level, they are trying to convince the society that both basic research and applied research are very, very important. So this is just to clarify. And then the ways how to collaborate, are a lot. So there are a lot of possibilities, and I am sure you have seen, for example, companies, big companies like you, sometimes finance research from academia that will be with benefit for your company, and this is good for both sides. Sometimes I have seen even more advanced cases in which the companies that have more financial possibility, because you have, we have a restricted, limited budget, and this is a problem for all the Western Balkans, because the percentage of dedicated to science is relatively low, and we are fighting, trying to convince the institutions to finance more. But for example, industries that buy, for example, an equipment, important equipment, they leave these to the academia, to university, for example, to centers, and people working in research make use of this equipment for your benefit, but at the same time doing some research. So, I mean, there are plenty of possibilities, and I'm sure that knowing each other, something will happen, and we want this to happen, because both sides, we are not experiencing such collaboration. This is something new in Albania, but as you said, nowadays the industries, companies, even in this region, are at a level in which you consider important the collaboration with the academia. So this should happen, and we wish to have some collaboration. So we may discuss also during the coffee break, but I'd like to thank you very much and invite colleagues here to discuss with you and be in contact. As I mentioned also, we have this big Congress of Nanotechnology. We'd like to have you again there, because it's important that you be in contact also with more people from the region. And I'm sure that there will be some collaboration. So thank you very much. And thanks for coming.
Other questions?
Hi, I'm Cosetta Nano. I'm Varus Merck Millipor Sigma Aldrich representative in Albania. Probably Professor Hitandra knows us very well. I'm glad that now finally in Albania it is API production site. As far as we know, API is highly regulated and normally it is for GMP application is very important. So it is not a question. I will follow your slides, and I wrote, we are the pond, we need water. I'd like to offer you to sit on a coffee break and to speak for probable collaboration, as we are the water solution. Millipor is the water solution. So thank you for being here finally in Albania, and we'd like to sit and discuss together. Thank you.
Other questions?
I just want to make a comment, and it's really, you mentioned about the GMP, and most of the students or graduates who are coming to the industry, they lack the GMP type of experience or knowledge. Industry, the first person when they're looking for employment, the first person is what kind of experience do you bring here? How can you generate the value for us? So my proposal is that the university should offer some quality classes, ISO, GMP, those kind of related classes. They should offer. It should be more, maybe after hours, not the part of the regular curriculum, but maybe after hours, something to whoever wants to attend, they can go and do that. But I think that's very important. Other thing is what I'm hearing is, I don't have a data, but I'm hearing that most of the large percentage of students after they graduate, they leave the country for the better opportunities. How can we keep them here? And that's where industry come in play. Okay, we have to, because government spends so much money for each student, and then the talent is leave, the talent gone. I'm the perfect example. My government, India, spent so much money for me to graduate. I went to US and I'm paying taxes in US. So how can we keep the talent here? And that's why AZ Group is a perfect example. I think they're the first pharmaceutical API company, and I think it should be supported to grow more.
Maybe another question or discussion? If not, I would like to thank the three gentlemen for the very nice presentation. And now it's time to have a common picture. So I will ask all of you to just gather in front and have a common picture for this event.
Sara? Sara në dëgjon?
Po, e dëgjoj.
Edhe ne të tjerë dëgjojmë.
Përshëndetje, profesor.
Përshëndetje, punë të mbarë gjithë dhe ju lumë bëni punë shkëlqyeshme.
Edhe ju. Professor, sorry, I can't hear you if you are speaking.
Okay, so let's start the second session for this workshop. Just I want to mention that we are a little bit late. So before losing appreciate time, I would like to re-invite the first speaker, which couldn't be connected for the first time, and she will be Dr. Dervishi, Sara Dervishi, which will hold the talk Assessment of Antiviral SARS-CoV-2 and Antibacterial Activity of Environmentally Friendly Nano-Coated Cement-Based Composite Tiles and Panels. So the floor is yours, Dr. Dervishi.
Professor, thank you very much. It's such a pleasure to be amongst you in this workshop and hear all these incredible research works by all of you. Well, imagine building materials that actually don't just shelter us, but protect us. That's the vision behind our project, which is called Antiviral and Antibacterial Activity of nano-coated cement-based composites. We are engineering surfaces that fight back against viruses, against bacteria, and as we'll see in this presentation, against pollutants, chemical pollutants too. Here we will be focused on degradation of rhodamine B in wastewater. You know, rhodamine B is everywhere in our industry, in textile industry, in factories, food factories, in paper manufacturing. It is pink. It is harmful. It is toxic. It is persistent, and it finds the way in our waterways because conventional treatment simply isn't good enough. Absorption, filtration, coagulation doesn't eliminate the problem. They just relocate it. So what we need is mineralization, destroying the dye in the molecule level and forming just carbon dioxide and water, no residue, no secondary pollutions. That's what our photocatalysts do. They work through redox reactions that generate hydroxyl and superoxide radicals that destroy the dye at the molecular level. This is the same mechanism that work with other pathogens like viruses and bacteria too. The same radicals can damage viral proteins, can damage envelope of virus, and also can degrade the nucleic acid of a virus. The question we set up to answer was what type of composite can do this and what type of composite can do this best. We have tested a family of photocatalysts, and today I will present to you our top performance, which are silver titanium dioxide supported in silica dioxide, silver titanium dioxide supported on nanograpphite oxide, copper oxide and magnesium oxide supported on titanium dioxide nanowires. Okay, to put this in context, here I have presented a schematic photocatalytic reactor. It consists of two containers. The first one is where photocatalytic reactions happen. It has a wastewater input and where the catalysts are in the right amount are put it should have air blowers on the bottom of it because it do the oxygenation of wastewater, which is very important to the mechanism of photocatalysis. And of course, open rooftop, which allows sunlight to go through the water. And the second tank is where the clean water is collected. It should have a conical bottom because there is where the catalyst is recollected and reused. Now, how can we produce the photocatalyst that works under sunlight? The three-step method is the answer. It starts with sol gel synthesis, which does a controlled precursor mixing for uniform nanoparticle formation, and also does a homogeneous distribution of the dopants at the molecular level. It goes to hydrothermal treatment, which improves the crystallinity of the sample. Grows the specific surface area, and for that reason, it increases the photocatalytic performance and reduces the electron-hole recombination. Also, in the last step, we have calcination. Calcination makes possible to reduce optical band gaps, and also to introduce oxygen vacancies, so we can have an enhanced catalytic activity and a visible light absorption on the sample. Now, go to the numbers. Our three top performance start with copper oxide, magnesium copper oxide, magnesium oxide supported in titanium dioxide nanowires, which in 120 minutes under sunlight, we have had 96% reduction of rhodamin B. Then you go with silver adopting titanium dioxide supported on nanographite oxide with rhodamin B degradation under sunlight, 90%, and then when we add silicon dioxide, we have degradation percentage around 83%. Here we have the UVV's absorption spectra that show the picture visually. So in 120 minutes under sunlight, we have for copper oxide and magnesium oxide only around 60% degradation of rhodamin B. Then when we add titanium dioxide nanowires, it almost degrade all rhodamin B, 96%. But what we saw is that when we added titanium dioxide nanoparticles, the performance actually dropped at 35%. What may have happened? We have done various assumptions, of course, based on research. What may have happened is agglomeration may have happened. Agglomerated titanium dioxide nanoparticles can bury copper oxide and magnesium oxide sites, active sites, contributing to net negative effect. May have been a defective heterojunction, so an uneven copper oxide magnesium oxide distribution that creates trap states of carriers, electron carriers. May have been an interphase recombination, and of course there is an inferior charge transport of titanium dioxide nanoparticles, 0D architecture compared to titanium dioxide nanowires. Of course, these are assumptions based on research, but we have to do various tests to confirm that, like SAM, XRD, etc. Here we have done the we have proceeded with the data. We have the graphs. The first one is the degradation percentage of the samples over time. We see that in 30 minutes, copper oxide, magnesium oxide has a similar degradation percentage of rhodamin B under sunlight compared to when we add titanium dioxide, but then the picture totally changes. On the second one, we have the same data, but on a concentration ratio, which is a normalized measurement of how much dye remains. And we see that for nanowires, titanium dioxide nanowires, it goes close to zero. What we have seen when we have done a Legmore-Hinshelwood first-order kinetic model is that cupric oxide, magnesium oxide, titanium supported on titanium dioxide nanowires degrades rhodamin B under sunlight 6.3 times faster than copper oxide and magnesium oxide alone, and of course 8 times faster than when we have titanium dioxide nanoparticles. We have done the same thing for silver doped in titanium dioxide systems. We see that both secondary supports such as nanographic oxide and silicon dioxide have both increased the photocatalytic properties of silver systems, of course, in different mechanisms. Nanographic oxides, what he does is that he acts like an electron acceptor. He pulls out the electron carriers away from the surface of titanium dioxide and reduces the electron recombination, so enhances the absorption of visible light on the sample. On the other hand, we have silicon dioxide that he increases the specific surface area of the sample and also improves the distribution of the sample grains. Both work, of course. What we saw in the first order kinetic model was that although silver titanium dioxide supported in silicon dioxide has a slightly lower degradation percentage of rhodamine B, but it degrades it 1.7 times faster than when we have added nanographic oxide, and of course 2 times faster than when we have silver doped in titanium dioxide alone. We also have done the FTR spectroscopy when we have seen in the molecular level by the stretching and bending vibration of the molecules for all the samples. And to sum up, we have 3 composite photocatalysts capable of degrading over 96% of rhodamine B under ordinary sunlight in 2 hours with no harmful byproducts. This is part of a broader program to create nanomaterial-coated building systems that actively clean the environment they're placed in, like treating wastewater, reducing pollutants, and building spaces that actually work for human health. So the pink river doesn't have to stay pink. We have the chemistry to change it. Thank you very much for your attention.
Thank you very much, Dr. Deravici. And now I would like to open the floor for questions or discussions regarding this presentation. If there are no... Okay, one question.
Sarah, regarding the project, have you finished all the activities that you have planned to do?
No, we have to do now the antiviral tests that we don't have still the base material to do it, like the reagents. So we are waiting for the reagents to come and we are ready to do the test, but we have the samples, we have done the samples.
Do you need any device, equipment for this? Last word?
No, we are in collaboration with the biological part of the faculty. So they have all the equipment. Also, we have had the needed equipment from the project that we have asked.
Okay, thank you.
Thank you.
Thank you very much, Sarah, for the presentation once again. And now I would like to invite the second speaker, which will be Mrs. Elda El-Mazlari, representative of Alpha Studio, with the presentation, Activity and Infrastructure of Environmental Laboratory. This presentation will be exceptionally in Albanian.
Përshëndetje të gjithëve, unë quhem Eldan Maslari dhe vi nga Alfa Studio. Laboratori jonë është kryesisht për analizat kimike, ekspertizën dhe monitorimin mjedisor. Në këtë prezantim do të përmbledhim historikun ton, fushat e aktiviteteve, pajisjet që ne përdorim dhe projektet tona kryesore. Historiku jon, kompania jonë është regjistruar në Qendrën Kombëtare të Biznesit në janar të vitit 2019 dhe në nëntor të po atij viti ka marrë statusin e akreditimit. Përsëri në 2023 kemi marrë statusin e riakreditimit me sukses. Fushat tona të aktiviteteve ndahen në 4 sektorë. Sektori jonë i parë është monitorimi i cilësisë së ajrit, i cili përfshin ajrin e ambientit, shkarkimet e gasta, monitorimin e cilësisë së ujit në mjediset e punës, si dhe parametrat e mikroklimës. Për sektorin e 2 dhe të 3, ne kryejmë analizat e ujit dhe të mostrave të ngurta. Për parametrat e ujit, ne kryejmë analizat fiziko-kimike, nutrientët, metalet, ionet kryesore, disa nga kompanimet organike dhe mikrobiologjike, por njësoj edhe për mostrat e ngurta. Dërsa në sektorin e 4 përfshihen monitorimi i zhurmave në mjedisin e jashtëm dhe të brendshëm, si dhe vibrimet. Kjo është infrastruktura jonë e laboratorit, i cili është i pajisur me ambiente të përshtatshme për zhvillimin e aktiviteteve që përfshihen brenda fushës së akreditimit. Këto janë disa nga ambientet e tjera. Përsa i përket infrastrukturës instrumentale, për monitorimin e plurave ne përdorim metoda gravimetrike dhe instrumentin optik me lazer. Metoda gravimetrike bazohet në mbledhjen e grimcave në filtra dhe më pas peshimin e tyre, ndërsa instrumenti optik matë numrin dhe madhësinë e grimcave, duke analizuar shpërndarjen e dritës. Për monitorimin e gazeve përdorim aparatura si Drager, PPB-Ray Plus, MSA dhe Aeroquali, të cilat kanë sensor, të cilat reagojnë me gaze të ndryshëm duke llogaritur përqendrimin në kohë reale. Për përcaktimin e lëndës së ngurtë ne përdorim tekora Isostat G4, i cili është parimi i kësaj është sonda merr mostrën nga oxhaku, e kalon nëpër linjën e ngrohur gazin dhe më pas ky gaz kalon nëpër 500 pingëra, ku secili nga gazet kapet nga solucione të përcaktuara. Më pas pompa thith gazin në rrjedhje konstante dhe regjistron parametrat që dalin në një panel kontrolli. Për gazet në oxhak përdorim Testo 350, është i njëjti parim si tek e para, por në këtë rast sonda merr mostrën nga oxhaku, e kalon përsëri në linjën e ngrohur dhe gazi analizohet nga qelizat, mace elektrokimike dhe parametrat e tjerë. Për analizat e ujit, për nutrientët, ne përdorim spektrofotometrin UV-vis, mostra vendoset në aparat dhe një rrezë dritë kalon në të. Aparati matë sa dritë kalon dhe kjo llogarit përqendrimin e substancës. Kurse për metalet, përdorin spektrofotometrin e absorbimit atomik me furr grafiti. Parimi i punës saj është që mostra futet në furrën e grafitit, ku kalon për fazën e programit të temperaturës dhe gjatë fazës së atomizimit, atomet e elementit në gjendje të lirë thithin rezatim nga llampa katodike. Dhe kjo sasi absorbuar është proporcionale me përqendrimin e elementit në mostrë. Këto janë disa nga aparaturat e tjera që ne përdorim për marrjen e mostrave, parametrat fiziko-kimike, disgardimin e të tjera. Gjithashtu kryejmë dhe matjen e zhurmave, të cilët përdorim një sonometër nga thirrur. Parametrat kryesore që ky aparat mat janë niveli i presionit të zhurmës, niveli i zhurmës ekuivalente, niveli maksimal dhe minimal. Që nga themelimi, Alfa Studio ka zhvilluar partneritete të shumta dhe ka kryer aktivitete të gjëra në fushën e monitorimit mjedisor, dhe këto janë disa nga kompanitë që ne kemi bashkëpunime, duke filluar që nga Agjencia Kombëtare e Mjedisit, Antea Cement, Alba Cement, Gener Dyshi dhe deri tek Devolt Hydropower dhe Universiteti Politeknik i Tiranës. Këto janë disa nga projektet tona që ne kryem të në bërë në partneritet me Agjencinë Kombëtare të Mjedisit për riparimin dhe mirëmbajtjen e pajisjeve për cilësinë e ajrit, me Universitetin Politeknik të Tiranës për monitorimin e implantit të ndrues në zonën e Triportit Vlorë, me Anteaçement për domethënë serviset individuale për monitorimin e mjedisit, si dhe analizën e ujit, tokës dhe të ajrit për hidrocentralin e Devollit. Këto janë disa nga fotot tona në terren. Objektivat e së ardhmes. Objektiva jonë kryesore është rritja e bashkëpunimit dhe zgjerimi i kompanive të cilat kërkojnë shërbime të analizave kimike. Përveç shërbimeve të monitorimeve, ne aspirojmë edhe rritjen e numrit të projekteve ku mund të përfshihet laboratori. Gjithashtu edhe rritjen e bashkëpunimeve që lidhen me problematika që has industria, si për shembull efikasiteti i implanteve të pastrimit të ujrave dhe analizat kimike të mostrave të ngurta, të mbetjeve të ngurta. Gjithashtu edhe përfshirja në projekte kombëtare dhe ndërkombëtare. Interesi në këtë takim, laboratori jonë synon që krahas këtyre analizave që ne kryem, të inkorporojmë edhe teknologji të shpejta, portable dhe inteligjente, siç është shkenca e nanoteknologjisë, duke përdorur nanosensor për monitorimin më efikas dhe më të qëndrueshëm të mjedisit. Sigurisht që këto kërkojnë një validim dhe standardizim të këtyre metodave, që të jenë të zbatueshme në laboratoret e akredituara. Faleminderit.
Thank you very much, Mrs. Elmazlari, for sharing with us the devices and methods you offer for collaboration. And now I open the floor for questions and discussions.
Po, atëherë unë po vazhdoj. Mbase nuk e vura re unë, ju keni apo jo akreditim? Kjo është pyetja, edhe për cilët indikator keni akreditim? Se nuk e pash atë dhe ajo duhet ishte ndoshta në mund të jetë defekti im. Edhe e dyta, ku është ISO special? Jo, pa është, okej. Edhe e dyta është sidomos për cilësinë e ujit në mjedis. Çfarë standardesh përdorni? Kujt i referoheni? Po kështu edhe për tokat nëse i bëni. Jo standardit të protokollit, standardit për limitet, për të vlerësuar statusin. Bëni ndonjë vlerësim apo thjesht bëni analiza pa vlerësim të statusit?
Ka rastisur që të kem dy aparate nga ato që ju paraqitët dhe jepni një ndryshim gati deri në 40% të vlerës. Ju që matë grincat në suspension, për më 10-ën, për më 2.5-ën, për më ju për kalibrimin e tyre, do me thënë ftoni
Another question? If not, I would like to thank once again Mrs. Elmazlari for the presentation. And now let's jump to the next talk, which will be nanobiosensors for pesticide residues in agriculture and food industries, presented from Professor Melinda Vasiari, which is also the co-coordinator of NanoAlb, NanoBalkan.
Okay, thank you, Kledi, for the introduction. I will have this presentation regarding the one of the nano-albignite projects that is now near the has started 2 years before, and now we have fulfilled all the results of our project. But also because this meeting is not just for the project, but it is wide in the participation with industry and other persons, I will give something more than the project, because I would like to show all the expertise that the group of analytical chemistry in the University of Tirana has in this direction. Also, we are part of NanoAlb, and we have a group that is the coordinator of this project. So the project is nanobiosensor for pesticide residues in agriculture and the food industry. We have been 3 partners in this project. As I said, my group is the coordinator. It is the group of Professor Giagiu, who also is part of Department of Chemistry, and the third partner, and very important one, was from ICN2 in Barcelona, the PhD Ruslan Alvarez, who has assisted us not in this project, but also in another project that we have more than 3 years that have been in collaboration especially in the field of fabricated of nanosensors. The aim of the project and an introduction of this field, I have done in other workshops that are organized to see the development and the implementation of the project. So I will go briefly. The aim is to develop some electrochemical printed sensor based on graphene oxide or reduced graphene oxide decorated with some heavy metals in the structure, in aiming to improve the analytical performance of those sensors. And these kind of sensor, and specifically the printed sensor, are very much developed and widely studied recently in different kind of fields, in environmental also, that we have done work for another project, but we are concentrated in the project financed by Academy of Science for pesticides in food and in agriculture. It means that the application of such sensor that we arrived to fabricate in our lab actually to apply in the samples from food and agriculture. Why it's important? Because the pesticides are extensively used, sometimes without any control, because it depends from the farmers, and also this extensive use of pesticides affect the environment, and from the environment to agricultural products, and enter in the food chain and arrived in the human's health. Also, it is known that there are some very good, very sophisticated techniques, like those that are chromatographic techniques, that did the analytical determination or quantification of pesticides, but always it is the need to find some other ways, alternative ways that have some advantages related with fast results, with low cost, portable devices and methods. And so those advantages are related to electrochemical ones. Mainly or specifically when we can use the printed sensors. The printed sensors modified with based on carbon and its modification have a lot of advantages because in the structure of a graphite we can introduce some functional groups that improve the analytical performance, the selectivity, mainly the sensitivity and the limit of detection. Also, printed electrode have another more advantages related to the production of a large number of electrodes, and the format of them is very good, very much reproducible. Now, here in this slide, I would like to show you that in the laboratory of sensor biosensor in the Department of Chemistry, which belong to the group of NanoAlb, we have arrived to establish three lines for printing technology for sensors. And this is related also with this project because two of them are supported very much from the project of Academy of Science. So we have this line, which is screen printing technology. It was the first one for printing, but it was used also because it has some advantages in production of sensors. It is based on some templates to print the electrode materials, to print the working electrode, the reference, or the counter electrode with the same materials or different materials as we want. Also, we have this capillary printed technology in the lab, but this is not from this project. This is from another project that we have, and it also finished this month. But the other technology based on laser engraver technology, using this laser device, X2, it calls, it is the main technology that we have used in the frame of this project, and the line of this printing based on laser engraver, it is supported very much through the project of Academy of Science. Also, the 3D printing technology, it is a device that we buy through this project, and it is very good device to help in printing sensor or mainly in accessory to use the sensor in the different kind of methods and techniques for different application. In this slide, I have mentioned some activities that are foreseen to do in the frame of the project of Nanopere, the project of Academy of Science. The activity begins from the preparation of printed sensor based on graphene oxide, reduced graphene oxide, and then incorporating the any metals in the structure of reduced graphene oxide. And then we have used for this different kind of metals as we have our previous experience or what we have seen in the literature. Then we have done the characterization of this material that we have produced to find if we have obtained what we intended to obtain. It means the chemical characterization or the state of the structure of the electrode materials, mainly the working electrode materials. And then we have planned to go to apply in the quantification of pesticides and to evaluate their performance. Also, we have appointed to do manuscript, to publish our work, and we have prepared a manuscript and sent for publication here in the how we have implement those activities. First, it was the installation of the printing system, and then the characterization, and then pesticide detection or quantification. But I would like to skip that slide because here I have some photo during this process. The first one here is the use of screen printing to print the connectors from silver that are here in this photo. And then it is here the solution of graphene oxide and the solution of metal salt going to mix together, and then by filtration, the materials form this thin film onto this filter. Here it is the device that we can use to reduce the graphene oxide and the cation of metal in the reduced graphene oxide and nanoparticles of the metal. And this film is transformed in this shape. And after that, here you see that are 8 electrodes, three electrode systems. We should test from using the conductivity if it is done or not what we aim to do. And then after we do this test, we use this hydraulic press to transfer the electrode from the first film onto the PET membrane, and these are the separated electrodes. All what I said, I can show this short video. The connectors prepared by screen printing, here are drying. This is the film, PET film with printed just the connectors. There are a lot of connectors, a lot of electrodes. Here it is the mixing of 2 solutions, and then vacuum filtration. So the thin film of electrode material is, here it is drying, and this filter with the film onto it. It is included, or it is put in the device of X-tool, and this is the layout of the electrode in the computer, which will do the formation of reduced graphene oxide and reduce cation of metal to nanoparticles. Here is the filter, which is cut in 8 pieces, 8 electrodes. It is the test of conductivity outside the electrode and inside the electrode to be sure that we have produced the reduced material. And then, very easily, the electrode can be transferred from the first film from the filter to the film using this hydraulic press. And here it is, the final electrode with the connectors, again the check of conductivity. So this is the whole process. So in other workshops in the beginning of the project, that each step of this procedure needs to do some optimization. And here are optimization of laser to do the reduction, and the hydraulic press to transfer the electrode into the PET membrane. So I am skipping this, but all this optimizing procedure, we use this optimal time 2 minutes. So with 11 ton with hydraulic press for 2 minutes, we can transfer successfully the electrode to the other film. The electrode that we have produced in this way, it is needed to do the characterization. As usually, we use the characterization by electrochemical method. which is cyclic voltammetry and impedance spectroscopy, to evaluate the reduction or the modifiers in the structure of reduced graphene oxide can improve or not the signal, the electrochemical signal. So here there are cyclic voltammetry recorded by different kinds of working material, and the difference is the metal that is included in those. And the impedance measurement, which allow us by some calculation to see if the process is reversible, reduction and oxidation, to see if the active surface of the electrode is increased, also to calculate the difference between two peaks, oxidation and reduction. And so we found that the nickel incorporated in reduced graphene oxide have the best of those properties to continue later. Also, here are some characterization regarding morphology and elemental composition of printed electrodes. Here it is same image that all those white points corresponds to nickel nanoparticles. The size of the points correspond not to atom, but to some atoms together, some aggregates, that corresponds to the metal nanoparticle. And the spectra in the other side, there are some nickel peaks that show us that really nickel is inside the structure. Also, there is a peak of carbon. This is very high. And also, here it is the, not here, but it is here. It is the peak of oxygen that we know that should be in the structure because it is a reduced graphene oxide. We have tested all the sensors provided, produced, using mixture of pesticides. We have used imidacloprid and thiometoxam together because they are some two pesticides that have similar functional group, so they could be reductive in the same potential. And really, we have two peaks here, and in the other voltammogram, they are not so defined, so good. So we confirm ourselves that we should continue with nickel in this work. Analytical performance need to do other experiments, not just the signal is or is not, but which is the sensitivity, which are the interferences that we have done all these experiments, which is the standard, relative standard deviation of the signal measured with the same sensor for different time. And here are our results, so that confirm that we are in a good way and we continue further. Now, I have selected two, from all the results, I have selected two voltammograms. One recorded with reduced graphene oxide and one with reduced graphene oxide and nickel. These are voltammograms and the corresponding calibration graphs, and that are done in the same experimental conditions, just the working electrode is different. And from those measurements, we have prepared here this table, where are the analytical performance parameters obtained with two kinds of sensor. And the most important is that imidacloprid measured with reduced graphene oxide and nickel has the low limit of detection. The sensitivity in the same linear range is 7 times higher. So it confirms that nickel really it is a very good modifier of the modifier of the reduced graphene oxide. We have done also experiments just to study in different direction our results. We have studied also the calibration. We have prepared the calibration graph using mixed standard with two pesticides, And we have also calculated the electrochemical performance, and we see that if it is another pesticide, the limit of detection, it is the same, but it is very near the first one that we obtained. After all those experiments and finding the analytical performance, we have validated the real samples with this sensor. The real samples has been mandarin and pepper, because from the media we have information that those two kind of vegetables resulted by media, not by laboratories, resulted with polluted with the content of pesticides. But with our sensor, because of our limit of detection, we couldn't find in pepper and in mandarin, here in the larger editions, and in this table using some lower editions of pesticides, we didn't find the pesticides in those two products. I don't say that there is not, but we say that the level of pesticides, if it is under our limit of detection. We have just one here, 0.18, but it is under our under limit of detection, so we cannot declare this value. But it seems that it is a signal that we can calculate it in this value. And how we evaluated such sensor in real samples? We are based mainly in the limit of in the recovery test. When we make additions of pesticides in the sample of vegetables, we calculated the concentration that we added and the concentration then we found through the sensor. And we saw that the recovery test in any case, it is around from 75% until 107. For organic pollutants, we in analytical chemistry say that this is acceptable recovery test for this technique. So now the calendar, the activities that we have planned to do for 2-year project, we have realized all. And the last one, it is this manuscript that we have prepared and sent for publication to the Journal of Academy of Science. We have received the review for one review, very good, without any corrections. It can be published. We are waiting for the second one and to see the publication. Which are the conclusions? In general, I have appointed very general conclusion, because we in our lab today have the installation or are able to print the sensor based on reduced graphene oxide or other materials, because we have screen printing, we have capillary printing, and this laser engraver. And it is established and it is tested, and we are very happy for this because we have good results in their application, not only in food samples, but also in water samples in the frame of another project. So we can fabricate graphene oxide printed sensor for application successfully in this that I said, but we are ready to test for other applications. And the other one is this preparation of this manuscript regarding all our work that we have done in the frame of the project of Academy of Science supported. So really, because this is a meeting together with a representative for companies, I would like to say that in this moment we are ready, we are ready to go further with this printing sensor technology. We think in our group to begin something like a new startup in the frame of the University of Tirana, but we have no experience in this direction, so maybe if we will not have any support of any collaboration for this kind of, to put this technology in a real function, I don't know how we can proceed. That's all that I was prepared to show you. Thank you very much for the attention. And if you have any questions.
Thank
Yes.
you very much, Melinda, for the nice and informative talk. And now I open the floor for questions or discussions.
Okay, congrats on the work is very, very interesting. And the idea that the opening, going for the startup approach is also very nice. So my question is it technology of printing sensor, is it patentable? Can you get a patent in?
What
Have you patent the process that you showed us?
Yes.
Is it, do you have patents on that?
No. No.
Okay.
We have not applied. We don't know. We cannot apply maybe
Did you develop
because
it
this is not
in-
a technology that we have discovered or is that do firstly in our lab. We have a collaboration with ICN2, as I said in the beginning. It is Ruslan Alvarez who has supported, collaborated very good with us in the frame of another European project, but we continue in this project also to the other application. So maybe they have to apply for patent, not us.
Yeah, and then another thing regarding those tests that you did on mandarins and peppers. My question is, can you just maybe contaminate on purpose some vegetables and fruits, and then check out if your sensor is
To
measured?
contaminate?
Yeah, you
and
contaminate on purpose to a certain level, and then check if your sensor is, fully equipped to measure the contamination level. For example, let's say, I don't know, whatever it is, a hazard limit from
0.3 ppm, it is our limit of detection.
perfect. And what is the maximum health level of this? For example, I have no idea. So
1,000 lower.
okay, we'll have 1,000.
I think
One-
I think that the use of sensor or the most important, I think, of the sensor is that if it is an accident with pollution, the sensor can detect very quickly. And then you can organize the monitoring, the whole study using chromatography or other techniques. But this is the most advantageous because it is very cheap, it is very quickly, it can be used from everyone just to put in the solution in the sample, and you have an indication about the situation. And this is good. This is okay because we have started with the addition of the samples. It means that those sensors works okay in this kind of matrix.
Thank you very much. Very nice.
Okay.
Does this technology, this methodology that you are using serve also to identify the level of azote, of nitrogens in the products, or only pesticides?
We have tried for pesticides, for heavy metals, for antibiotics. I don't know if
Nitrogen can be found?
nitrogen indirectly, yeah. Yeah. A pre-step of the sample.
Because we might be interested to collaborate with you if you can identify this. we have a product, a bioactive product with amino acids, and we would be interested to see the carenza time of this product. So how much days before the raping of writing the products, can we use our product in order that it doesn't leave residues of nitrogen, because they are amino acids and they transform in azote.
But we can quantify the amino acid and the reduction. Which amino?
Yeah, we can send the aminogram.
Much.
Yes, we are very interested because our product has very good impact on the plants, but we are not recommending them to use from a certain date to the collecting of the fruits. And we'd like to know what is the maximum or the minimum time that they cannot use our products without leaving residues in the...
Okay.
Another question or discussion? If not, I would like to thank once more Linda for the very nice presentation. And now let's jump to the next presentation, which will be compliance in research and industry, the importance of cooperation between institution, academia, and private sector. And this presentation will be held from Elton Hode, which is a state export control authority. So, Elton Hode? If not, we'll jump to the next presentation, which is ensuring proper water quality in scientific research with molecular water purification systems. And this presentation will be held from Anastasios Afratis, which is a field sales specialist from Lab Water Solution of Merck Group. So the floor is yours.
Thank you.
You can use that.
Okay. Hello, good afternoon to everybody. My name is Fanos Afratis, and I'm a field sales specialist in Lab Water Division in Merck, and covering market needs in a big part of Southeast Europe. So I'm very happy here to be with you in the 5th Nanotech workshop. And I would like to talk about ensuring the proper water quality in scientific research with molecular water purification systems. Whether we have analytical chemistry or molecular biology or pharmaceutical research, the quality of lab water determines the quality of scientific results. We in Merck, we develop and produce innovative, modern, and sustainable lab water systems since 1967, almost 60 years now. So in Merck, we have three fundamental pillars: life science, healthcare, and electronics. In life science, we serve our customers from research to large-scale production with more than 300,000 products. We offer unique, well-known brands like Sigma Aldrich, Supelco, Millipore, Sigma Aldrich Fine Chemicals, BioReliance, and our focus, the MilliQ brand. MilliQ stands for Millipore Quality, and MilliQ portfolio ensures that the quality that scientists need in order to have accurate and reliable results. But all purified water has the same characteristics. Here, in principle, we have three types of reagent-grade water. At the bottom of the quality pyramid, we have type 3, which is reverse osmosis water, but its quality is not stable. It depends on RO condition. So generally, we can say that its resistivity is lower than 1 megaohm and is suitable for applications like autoclaves, water baths, animal feed, hydroponics, and non-critical rinsing. In the middle of the quality pyramid, we have type 2, or pure water, which has a resistivity between 1 and 15 megaohms and is suitable for titration, pH measurement, UVV's sample preparation, microbiology, histology, dissolution testing, glassware rinsing, stability chambers. And in the top of the quality pyramid, we have ultra pure or type 1 water, which has a fixed resistivity of 18.2 megaohms and is suitable for all analytical techniques, even trace metal analysis, for cell and molecular biology, for protein research, for genomics, and specific removal. But if we remove ions from water, is it all ions? Is it enough to characterize it as ultra pure water? No, because except ions, in water we have organics, natural or artificial origin. We have microorganisms like bacteria, fungi, algae, and their byproducts. We have particles and colloids. And finally, we have dissolved gases, like carbon dioxide. As you know, ultra-pure water is not a stable form of water. It has the tendency to absorb all airborne contaminants in order to return to its previous state. So that's why ultra-pure water must be prepared and consumed while it's fresh. So in order to achieve that, we need to have intermediate water quality, type 3, or even better, type 2, stored in a reservoir and ready to be used in order to produce ultra-pure water. So in the pretreatment procedure, we have several purification techniques. The most important is the reverse osmosis technique, which can retain all kinds of contaminants, organic ions, particles, and bacteria in a very good level, in a very good percentage, up to 99%, but not 100%. Downstream reverse osmosis, we have the EDI module, which removes ions with the addition of electrical current. This way, we have high constant and high purity water, type 2 water, and with extended lifetime, because EDI module has a big lifetime. And so this way, we have reduced the running costs of pretreated water. Then we can have two bactericidal lamps. And in the polishing side, we can have photooxidation UV lamp in order to reduce TOC. And we have the polishing cartridge in order to absorb traces of organics, and ion exchange resin in order to produce the type 1 water. What is also important is that we have the final filters are application specific filters. What do I mean by that? Is that we have 6 different pod packs, like millipack, which is a 0.22 micrometer screen filter. So it produces bacteria-free and particulate-free water. We have LC-pack for sensitive, ultra-trace organic sensitive applications, especially like LC-MS-MS. And it contains carbon-18 silica beads. Also, we have two pod packs with synthetic activated carbon. The one can absorb volatile organic compounds, and the second one can absorb endocrine disruptors. And finally, we have the biopack, which produces pyrogen, nuclease, protease, and bacteria-free water. And this is based on ultrafiltration. So now let's start our journey in lab water systems. We have launched the 7th generation of MilliQ systems, which is the MilliQ IQ series. And I stand for intelligent. So back in 2007, we launched the MilliQ IQ 7000, which is a pure to ultra pure water system. And the concept is that we have one unit that purifies water and a separated second unit, the Q-pod, which is next to it, which delivers type 1 water with a flow of 2 liters per minute. Then 1 year later, we have launched the 2-in-1 solution, the MilliQ IQ 7000 XX. So it's one system that produces 2 water qualities, type 2 and type 1. The delivery of type 1 water is from Q-pod, and respectively, the delivery of type 2 water is from an E-pod. And E-pod is the one with the red dispensing, the red color. And in 1 year later, at the end of 2019, we launched a specific to trace elemental analysis pod, the MilliQ IQ element. This is specific for those who perform ICP-MS experiments. And finally, 1 year later, we launched the MilliQ IX systems, which are tap to type 2 water. So now let's talk what are the main features of the MilliQ IQ 7 series. We have versatile configurations because we have 4 different flow rates. And if we want to achieve more flow rate, we can have up to 3 systems connected to the same tank. Also, if a scientist has several applications, we can have up to 4 different pods with a different pod pack each in order to fulfill his experiments. And these systems can be installed on the bench, under bench, or can be wall mounted. Also, these are the first systems that are completely mercury-free. We have UV lamps that are based on LED or excimer technology with no mercury at all. And also we have some features that can save water during rinsing mode. 3 sizes of tanks are available, 25, 50, and 100 liter. The challenge here is to preserve the pure water quality. And this is done by 2 built-in features. The first one is the vent filter, which prevents airborne contamination from substances like volatile organic compounds, carbon dioxide, and particulates. The second built-in feature is the automatic sanitization module, where we have an integrated UVC LED lamp, which prevents bacteria growth and biofilm formation. Then we have the E-pods and the Q-pods, which are compact, ergonomic, and intuitive, and make lab work effortless. We have 3 ways to take water from the pods. The first one is manually or variable flow. So manually, we just press the dispensing wheel on the pod, and one to start, and one we press it again to stop. But also the dispensing wheel has can rotate to 8 different positions, resembling to 8 different flows, from drop by drop till the full flow of 2 liters per minute. The second way to take water is the volumetric dispensing, where we can program the final volume from 20 ml till 100 liters. And the third way is the assisted dispensing, where a preset volume is registered and has a drop-by-drop finish in order to avoid contamination from intermediate containers like squeeze bottles. Also, we have an easy interface to communicate with the system. We have data management, we have remote capabilities, we offer validation services, we offer accessories, and easy to replace purification packs. So with these techniques and these features, we guarantee a minimum quality with resistivity less than 18.2 megaohms, TOC less than 5 ppb, and bacteria less than 0.01 CFU per ml. Now let's continue on journey in time, and in 2021, we launched the MilliQ EQ series, and E stands for essential. We have 2 systems. We have MilliQ EQ 7000, which is a pure to ultra pure water system. And 1 year later, we have MilliQ EQ 7008 and 16, which is a tap to ultra pure water system with an intermediate quality of type 3 water. So there are several similarities with the IQ series, like the 2 liter per minute ultra pure water dispensing. We have installation flexibility where we can mount the Q-pod in the system in 4 different positions. We have a touchscreen, traceability. We have the same enhanced purification cartridges. And we have but what is different is that we have an inline TOC indicator and check and dispense lights. And finally, in 2024, we launched our MilliQ SQ series, and S means simple. So it is a simple system, the MilliQ SQ, which consists of an narrow water production station with a switch tank and an ultra pure water dispensing module with its own switch tank. Ultra pure water is produced fresh by a handset dispenser, which is equipped with an application-focused final filter, either 0.22 micrometers or UF BioPack final filter. The concept behind the idea of the MilliQ SQ series is that we can have a switch tank, a 3.5 empty switch tank, docked in the purification side, and which fills with very quickly with RO water from a high-capacity RO membrane, which can be up to 42 liters per hour. Then the user can easily carry the switch tank to the ultra pure unit. The ultra pure unit can be on another bench, on another lab, even on another floor, and dock the switch tank in the place of an empty tank. So user can dispense 3.5 liters of freshly produced 18.2 megaohms ultra pure water. And the user can take back the switch tank and put it back on the RO side. So we have an interchangeable tanks, 2 interchangeable tanks. And this is a cycle process that can be repeated as many times needed during the day. We have 6 different members in this family. We have the standard configuration of MilliQ SQ 240. This is for labs who require minimum ultra pure water. But if somebody wants more ultra pure water, we can have the MilliQSQ 240L for large, where we have two switch tank in the arrow production side. Also, we can have the extra large configuration where we have a 50-liter tank for direct feed of an instrument, of a lab instrument, let's say for dishwashers. And then we have the MilliQSQ 240C. C is for combined, where we have a fixed arrow production station with ultra pure water station and a switch tank in between. And then we have the MilliQSQ 240CV combined and preset volume, where we have also the volumetric dispensing, but we don't have a handheld dispenser. We have a fixed dispensing point. And finally, we have a MilliQSQ 200P for pressurized if the feed water is coming from a loop. So just to summarize and to conclude, we have three tiering options. We have the MilliQSQ for essential needs, for easy dispensing, for do-it-yourself installation. But if customer wants an HMI, human-machine interface, with monitoring in conductivity and temperature parameters, wants data management, advanced dispensing options, and is application focused, then MilliQ is the right solution for him. And finally, if a customer wants more flexibility, TOC monitoring, more sophisticated dispensing options, data management, sustainable features, validation services, and connectivity, then the right solution is MilliQ IQ. So all these that we have said are in a flyer with a QR code where you can scan them and download these three brochures about the systems we talked and about the purity of water and what to do and what not to do with ultra pure water. I would like to thank you for your time and your focus.
Thank you very much, Mr. Afratis, for this very informative talk. Every chemist, every nanotechnologist and scientist needs pure water, so this talk is exactly for us. I open now the floor for questions and discussions. If there are no, I would like to ask one question regarding the upgrading of the device. If one has a device of 2017 and wants to upgrade it to the latest technology, is it possible to just changing any module inside, or you have to change the whole system?
No, we have, what we can add is more pods or more systems in one tank. This is what is scalable for us. So if we want, let's say, if a customer is doing HPLC but wants to do also molecular biology, we can add a second pod. But if he wants has a system for pure to ultra pure, then we have to buy another one to make the pretreatment stage.
Okay, thank you. Thank you very much. So now let's jump to the final presentation, which will be scanning electron microscopy applications in nanoscience. And it will be held from Mr. Dušan Popović, a representative of
Good afternoon to everybody. I'm glad to be here on this fifth Nanotech Science Conference or workshop. My name is Dušan Popović, and I would like to discuss about scanning electron microscope from Thermo Fisher Scientific and appliance in nanotechnology. Maybe you heard about Thermo Fisher Scientific, but you haven't heard for them or you're not connecting them with electron microscopes, and you think maybe they're novel with this, but actually this is a start with the Philips, which is a brand name in this area. They produce first TM, not first TM, but first TM for customers in 1931. And they work a long time with this technology. In 1997, Philips sold his actions of the company to FEI, which continued to exist until 2017, when Thermo Fisher Scientific acquired whole FEI company. FEI company is now more or less part of the Thermo Fisher Scientific, but still it's remaining more or less for itself, and it's continued to develop good products and continue with quality, which was known to us even before they were merged with the Thermo Fisher Scientific. In our portfolio, we have scanning electron microscopes, desktop scanning electron microscopes, and dual beam systems. These are systems which are coupling electron column with a focused ion beam column on the angle on the side, which give you even in-depth view of your sample. So you're able to done more comparing to just a scanning electron microscope. And then we have transmission electron microscope. Depending on the system and configuration, you could get atomic resolution of your sample, but sample need to be prepared. So we need a thin TEM lamella, which should be, let's say, less than 50 nanometers thin. If you have this question during your experiments or your scientific work, what is my grain size, what is the particle distribution, or is my sample homogeneous, which elements are present, is my sample amorphous, then electron microscope is right tool for you. So all these questions could be reduced to just a couple of these questions: how my material will behave, and why did my material fail? So during experiment or in research and development, or if you want to really have control of your material, you would like to control your process during production. And when something is failing, you want to know what get wrong. So this is what we could get with a scanning electron microscope. Thermo Fisher Scientific has a complete portfolio of scanning electron microscopes, which could be used in material science with different application. Depending on application which you use, you could choose system which is going to suit you the best. In the lower part, we have a desktop scanning electron microscope with the brand name Phenom, and they have these characteristics. So time to image, so they're fast. If you have a small sample, you could just put it in, and in a couple of minutes you will already have image, and with one click you will have also chemical characterization of your sample. Easy of use. So software on this system is designed for novel users or for users which are not microscopists. So it is easy, and you could learn software in a couple of maybe hours or one day. So you could even start with your experiment. If your sample is more demanding, you will need something from floor models. So we have here tungsten SEM with tungsten column, and also SEMs with field emission gun. So depending on needs, there are solutions for you. So if you need maybe a low vacuum or even lower vacuum in the chamber, or if you want to get high resolution or ultra high resolution with your sample, then we could choose a suitable solution for you. If we speak about desktop SEMs, I will just dedicate a little time for a Phenom XL. So this is a desktop SEM. which means it is small. It have low pre-installation requirements. So if you have a desk which could support 70 to 80 kilos, and it's enough wide for a SEM and computer, you could already have it in your room. So you don't need a special room for SEM where you need to work with it. It has cerium hexaborate source, which is now improved and could last for 3,000 hours. So you will have a lot of time, and it's also guaranteed, so even more depending system to system, and you will have a lot of time to work before you need to call a service for exchange. As I said, it has integrated components in software, and it is really meant to increase speed, how you're going to get to your result, and not to wasting time with sample. And this is also hardware base for a phenom perception particle analysis software, which is doing automatic feature analysis and could be applied in a steel inclusion analysis, battery contamination if you're getting battery powder, and also technical cleanliness. So this is developed for automotive industry, but also could be used in another field. I jump a little bit. So I just wanted here to show you that even with phenom, you could see small particle. You're not going to really see the surface of the particle, but with no trouble, you could go and check particle of 300 nanometers, and even this is not the maximum of the system. Next system is Axia Chemisem. It is also developed to help you with productivity, to be flexible, and to be easy to use. So when I said productivity, it is pumping down time is really fast, so you're not going to waste any time when you are exchanging your samples. And also it has integrated EDS detector. It is integrated also in the software, and you could really fast get to your chemical chemical analysis of your sample. It could accommodate heavy samples and also tall samples because of design of the chamber. So if you have some large sample which you don't want to destroy to prepare it for SEM, you could maybe put it inside and just make images. When I said easy to use, it has simple alignment. It's always aligned, and there is a user guidance which is also hyperlinked with functions in a system UI, which is link you directly to where you want to go. It has also pre-centered and preheated filaments, which could be used for a faster filament exchange. But also you can use the standard legacy filaments depending on your demands. And I will just want also to show you, this is a user interface. So here in the third quadrant, you could see your sample stage from above. So it is easier to know where are you. And if you click on this position or any position, this position will go directly below the column, and you don't need to search where your sample is. Also, fourth quadrant is for CCD camera. So you could always be aware how far from final length are you, because we want to avoid damaging the system. And now, so this animation should show you how fast you can vent the chamber, take sample out and replace them with another sample, and then pump down the pump down system again. So also this CCD camera is behind, so you could see yourself when you're pulling out samples. and then just pressing pump is going to use 2 minutes and be ready for you. Quattro SEM is will enable you to have high resolution imaging of any sample in any conditions. It has highly stable field emission gun source and column, but also it enables you to use low vacuum and environmental SEM for samples which cannot tolerate to be in a high vacuum, like biofilms. You could use this system and again have high resolution images of those samples. It is it has a lot of accessories. So it has a Peltier cooling stage, which could give you temperature range from -25 to up to 50 Celsius. Also, you can change relative humidity, and also you could be in any vacuum mode. Then you have a ESEM heating stage. So this is in environmental SEM modes with lower vacuum in the chamber, and you could heat up your samples if this is interesting for your research. And at the end, you have a high vacuum heating stage where you could heat up your sample in a high vacuum. And also you can use ETD detector to get image of your sample. Again, Quattro could also have a wet stamp technology, and here we could see silver nanoparticles in water. So they are in this wet stamp stage, and here is a bright field. So you can see that the particles are dark because they are dispersing electrons, and here is HADF when they are white because electrons are hitting this ring of the detector. What is interesting for a wet stem, this stage could give you transmission image with the stem detector, but also if you want to keep up humidity and work with the bulk sample, you could use the same stage with your system. And let me now introduce Apreo Chemisem. This is newest system. It combines scanning electron microscope with energy dispersive X-ray spectroscopy to give you chemical analysis of your sample, and also with EBSD, electron-based scattering diffraction, which could give you your structural characterization of your sample. In the heart of the column is a Trinity detection system, which could give you, first is T1, it is giving you material contrast, so it is more backscatter detectors. Then you have T2, which is giving you topographical contrast, and then there is a T3, which is giving you surface contrast. What is interesting with this system is actually this in-lens detection, which are great if your samples are beam sensitive, and then you need to reduce kilovolts of electrons which are going on your sample. So when you want to work with lower kilovolts, then you need to get high resolution, you would use these detectors in the column. So here we could highlight ultimate imaging performance. These are aluminum oxide nanoparticles, and this is a polymer separator for batteries. And here you can see really surface on both image. And if you want to have high magnification image, there is no lag. You could have this great image in your bag because we have auto functions. So autofocus, you can see it in animation, auto-stigmation, and auto lens alignment. If you're a novel user to the microscopy, or you have some SEM expert which move it on, you could easily get your high resolution images with these auto functions, which really works. So I'm not sure how much time they have. Right. If you want to then to just see the movie up to the end. So now he is using autostigmator to stigmate the image. And then again, autofocus. Again, autostigmator. This what we also, when we want to get high resolution image, we needed to do manually. But now with auto functions, it is much easier for novel users. And then you could check these images, which are also used on the previous slide. And then just briefly, I would like to present a thermal scientific TM portfolio. So we have first Talos family, Talos 12, which is a system which could be used in life science and material science. It is easier to use. Then we have Talos F200i. This model it is flexible, so it could be configured. And then if you really want a good model for with 200K high tension, so it is actually from 30 to 200 kilovolt high tension range. So there is a Talos 200X. This Spectre family, this is already advanced TM systems where you need to have some experience with TMs. I mean, they're also simplified with, let's say, auto STM, auto mono, and other functions, auto align, other functions which will enable you to really get to the image. But as system is higher, it needs more, it's more demanding for operator, and also it's more demanding regarding installation requirements. And then at the end, this is a new system, Iliads. It is similar to Spectra. It just has new electron energy loss spectroscopy, which is produced with Thermo Fisher Scientific, and it is fully integrated hardware plus software with our transmission electron microscope. And YTEM with the nanoparticles, you could have your nanoparticle, you can see your nanoparticles, but also they are false colored by element, which is mostly present in them. This is done with EDS, and this is the map which is collected in just 60 seconds. And then with additional softwares, we could also have data and spread of these nanoparticles by elemental composition and also size. That's all. Thank you very much.
Thank you very much, Mr. Thank you very much, Mr. Popovic, for the nice presentation and very informative. I now open the floor for questions and discussions.
Thank you very much for the presentation. And all these are very important tools for all the people working in nanotechnology. My question is your company collaborating in research and development with academia, for example, in the region? And if yes, what kind of way you are using, so in which way you collaborate? Because we are very much interested, as I said before, also with other companies, but your company is very, very important also. And given the lack of infrastructure, sometimes it would be interesting ways to collaborate with industry. I have seen in other countries in which, for example, companies like you lead the instrument to a center and they are using it, doing some research for your interest, also dissemination of your capability and things like that, and even some projects like PhD or master projects with interest for the company. And this is a kind of, as I said before, with interest for both.
Well, I think maybe if you would like to acquire TM plus something for preparation, probably because you don't have it in your country, and some kind of discount could be approved. But these are really expensive systems, so I think yes, but they're already somewhere in advanced TM, and so they already have some TM, and then they're trying to improve it. Then like there's a university in Switzerland, and they're trying to develop something new with TM to add, because yes, because we are already really advanced with TM. I mean, this collaboration was back in the past in Czechia with the institute in Brno, and now they're actually acquired part of this institute and open factory over there. So I think it was Nikola Tesla Institute in Brno, but it was like 20 years ago, maybe.
Or European projects or even national calls, you are allowed to participate as partners? Are you interested to do that?
Well, I mean, maybe we could help you with writing projects, but these are
okay. So these are
I would need to consult with somebody.
Okay, thank you. Another question? Okay.
Okay, thank you for the nice presentation. I was wondering, your company is located where exactly?
You mean Thermo Fisher Scientific?
Yeah.
Thermo Fisher Scientific is a global company with a lot of production site. But if we are speaking about just electron microscopy, they have in Eindhoven-Acht, there is this production site where they're producing high-end TMs, and also in Brno there is a big company, a big building where they're producing Talos family and also scanning electron microscope. Part of the company is also in Hillsborough in USA. There is a production site for FIB columns, so focused ion beam columns, which are shipped, and then if we are producing this dual beam in Brno, then they're assembled here in Europe.
I see. So you probably represent the whole Balkan region, I guess. You are the distributor also yourself.
So there are in Slovenia their representative ITR, and it is I think for Slovenia and Croatia, and in Serbia is analysis, which is also for some part of the Balkan area.
Great. So one technical.
And also in Greece, I think that there is also representative, and Bulgaria. So.
Okay. One technical question. You do make microprobe mapping with SEMs, I guess?
Sorry?
Microprobe mapping of samples using SEMs? You know, they have these elements. I mean, you're mentioning this chemical composition of the samples you have. But do you do the whole mapping of some certain area when you can track how the elements are distributed over the surface?
I mean, if we speak with SEM, so SEM is
we call it microprobe. Yeah. The elements, I know. But do you do only spot analysis? Because I know that. I mean, you get the X-ray analysis afterwards, and then You get the spectrum, from the spectrum, you know which elements are present there, but do the whole mapping of the surface so you can, okay. Yeah, of course, it takes time, yeah. Yeah, okay, yeah, okay. Yeah. Yes. Great. All right. Yeah, I know I've seen. So at least you have. Okay. Yeah. Cover the whole area. Yeah, you see from, yeah. Yeah, nice, very nice. Yeah. Yeah. The thing is that your university at Tirana here, I don't think you have SEMs, do you?
We have one SEM, which is actually located at the Polytechnic University of Tirana. So, other questions? If not, I would like to ask maybe two questions. The first one relates to one of the simplest desktop SEMs you already presented. Is it equipped with an EDS or not?
Yes. Actually, so you have a ProX model, which comes as default comes with EDS, and this XL model, which could accommodate more samples, could be configured.
So even the simplest one has an EDS.
Yes. And it's also it is again it is integrated with hardware, so it's not maybe the best EDS in the class, but it's really integrated, so it is fastest actually. Even could be compared with a standalone SEMs.
And my second question is related to actually the SEMs which are equipped with FIB. So in order to study the profile of a certain sample, you need to open such profile, and FIB is quite often used. Are there these?
Yes, actually, in presentation, it is called the dual beam systems. So they have an electron column and Fib column, so focused ion beam. Standardly, again, the focused ion beam was done with gallium ions, but now there are other solutions which could use plasma Fib, and then you have also Hydra system, which could have different gases for plasma. But then again, the price is going up.
Is it possible to upgrade later on if you buy a simple, let's say SEM, then add such module?
No. If you would like to have a dual beam system, then it needs to be dual beam system. So there is there is a size which is more affordable one. It has this Prio column and then additional Fib column, gallium Fib column on the side, and then you can use this cross section to check how your profile is going. And additionally, you can make TM lamellas and maybe even with additional software, so you can make image of the surface, then destroy the surface with a focused ion beam, then another image, and let's say go in the depth profiling of one area of sample. But again, I used time slot, like maybe I shortened up presentation and didn't focus it additionally on dual beam systems.
Thank you very much. SEM and PMs are very, very important for nanotechnologists and scientists.
Yes. I hope when you start with the EU, then maybe some funds and some projects will come, and then, I mean, maybe just one nano center should be sufficient for.
We are looking forward.
Okay.
Well, thank you once again, and now I open the.
Thank you very much.
Let's say exactly the floor to Professor Mercoci once again to make the closure remarks for this workshop.
Thank you very much. First of all, I would like to again thank you very much, colleagues from Industria, to be here. It's something new for us, of course, although we have several years that we have been doing this activity, but this time we see more interesting topics from industry that may be with interest also for the collaboration. And of course, all the colleagues from academia here and those who are in the online. As you all know, the ways to collaborate are different. I hope that from master thesis, PhD thesis, common projects together, national project, European projects, the private project from the industry, I think all the research groups from Nano Balkan, Nano Alb will be interested. So we'll be waiting your suggestions, requests for collaboration. So you know from this workshop what different groups are doing, but we have more information in the website of Nano Balkan. So if there is something that attracts your attention and you have some ideas on how to collaborate, we will be really very, very interested to discuss with you in separate meetings and see how we can work together, because we all are interested to collaborate. So this is all from my side. And the last thing is that we'll be very happy to have you, all the people from Industria in the Nano Balkan conference from 26th to 29th of October. Just have a look to the website, Nano Balkan 2026, and you'll see there an impressive list of invited keynote speakers from all over the world. And as I said this morning, everyone will be very happy to have you there and to hear collaboration opportunities. So don't miss this opportunity. So write to the information, to the website, and of course to Cledin, Linda, who has been coordinating this workshop. So again, and I would like to thank both Cledin and Linda for the great job, and all the people who have been involved in this workshop. And thank you very much, and see you next time. So we are insisting, organizing this workshop frequently, because we consider that we are growing and probably will have more opportunities to show things that may be of interest. And without you, we cannot bring the things to the market, because all the development in science, in academia, should be done hand by hand with industry. So thank you very much.
A great day to everyone.